Currently we executed this particular API, that is get mapping fetch department by ID. So for this particular thing, let's implement the error handling. We'll be creating here custom exception over here, and we will throw that particular custom exception and we will handle it. So let me just create that. Let me just stop the server. Let me create one of the package over here. Okay, I'll create the package error over here, and I'll create one of the custom exception that I'll say department not found exception. This particular department not found exception will extends exception over here. Let me override all of the methods over here. Okay, I'll do exception with string message, exception with string and throwable with just throwable, and exception with string, throwable and suppressions. Okay, so I'm just overriding all these particular methods over here in this particular class. Okay, so we just defined one of the custom exceptions. Now we will throw this particular custom exception when there is no data present. We will say department not found. So let me go to the service layer, because that's the particular layer that we are getting the data. If you go to this fetch department by ID, right, this is the particular method that we are getting the data, and here you can see that we are directly getting this particular data. But if there is no data present, then we have to handle it over here. So let's change this particular file over here. Now here you can see that we are directly returning it. So first let's change that particular thing. Okay, this particular find by ID is returning the optional of a department. So let's first get that particular value. We'll just say optional of department over here. We'll say department, and we'll remove this particular get over here. Simple, right? We are getting the optional of department from this find by ID method. Now what we will do, we will check if this particular department, whatever we are getting from the database, is present or not. If it's present, that's fine. If it's not present, then we should throw the exception, that is department not found. So what we'll do, we'll just say over here if not of department dot is present. Okay, if department is not present, then we'll say throw new department not found exception, and we'll pass department not available. And then if you have found the department, we will just say return department dot get. Simple over here, right? Now here it is saying that we should add the exception to the method signature. So let's add this. Here you can see that it's asking us to add in the entire hierarchy as well. So we'll just add it. So here you can see that it would have added in the service as well. And if you go to the controller, let's see if it's added or not. Here you can see that. So here also let's add to the method signature for now, okay, for the simplicity. But we can handle all such kind of exceptions at the controller layer, and we can throw different kind of messages based on those exceptions that we have. So what we did over here, we just added one of the exceptions over here, and we added a meaningful message over here. So let's see how it is working now. Server started. Currently, at last time when we saw that, you can see that the message was no value present. Now if I save the data, and if I go back to the department, and if I hit send, you can see that we still got the same error, same big stack trace and everything. But at the end, you can see that the message was department not available. So this was the message that we added. But still we don't want this. We want to clear it out, the entire response. We want to have a meaningful response. So let's go ahead and implement that as well. So what we have to do is now, whenever there is an exception occurring at the controller layer, we have to fetch that, or we have to identify that this is the exception thrown, and whenever that particular exception is that, what we have to send back the data as a response, that we have to configure over here. So what we'll do, we will create one of the class over here, and that class will be responsible for sending all the response back based on the exception that has been thrown. So for that, let's create one of the class over here. In the error only, we will say REST response entity exception handler. Okay, So this is the particular class that will handle all the particular exceptions that we want to send back as a response entity, and this particular class will extend response entity exception handler. Now whatever the class that you are creating to handle all your exceptions, okay, that particular class should be annotated with @controller advice. Now this particular controller advice, currently we are adding for all the controllers that we have, but if you want to add this particular controller advice for a specific controller or a specific base package, that also we can do. So for those particular controllers and for those particular base package only, this particular advice will run when there is an exception occurred on all those particular controllers. So currently what we did, whenever there is an exception in my controller and that particular exception is been thrown, this particular controller advice, this particular exception handler will handle those kind of exception, and it will create a response for that particular exception, and it will send back as the response object. So here we define that this particular class will be the controller advice, and we'll also define this particular class will send the response status. Okay, now we have to create one method, and that method will be responsible to handle that particular kind of exception. So currently we created department not found exception, so we will create a method that will handle that particular exception itself, and whenever that particular exception is been thrown, what we want to send back as a response, that we will give over here. So let's create the method over here. We'll say public what I want to send over here. Okay, so let me just create one of the entity class or Pojo class, whatever you want to tell. Okay, so I'll just say error message over here. This is the class that I'm going to create, and I'll say department not found exception is the method name. Let me just create this particular class over here. First I'll go to the entity and I'll create this particular class. Now this particular class we will be sending back. So what data I want to send back, that I want to define over here. So I want to send HTTP status over here. First, what is the status? 200, 500, 404, whatever. So that I want to send, and the other thing that I want to send is the error message. Okay, these two things. Now this particular class should have data setters and two string methods and everything. So let me annotate with @data using Lombok. I'll create the no argument constructor and also create the all argument constructor over here. So simple over here. We created a Pojo class over here, okay, with two of the properties. And this particular, let me just import the package. Now this particular method will take department not found exception as the input parameter, plus it will take web request as the input parameter, and we have to annotate this particular method with exception handler. So we'll just define exception handler and what type of exception this particular method is handling. So we'll say this is handling department not found exception dot class. So now it's pretty much clear over here that this particular method is handling this exception, and it is taking department not found exception as the input parameter plus web request as the input parameter. Now we can create that particular error message as the response, and we can send back. So let's do that. So we'll just say error message, and one more thing to note over here is that this particular error message we need to send as the response entity. So I'll just wrap around this particular error message as the response entity. Here I'll define error message equals to new error message, and this particular error message I'll give HTTP status dot not found, that is 404, okay, plus I'll pass the message I'll get from the department not found exception dot, okay, this is the exception over here, this is the name of the variable, so exception dot get message. Okay, so we created the class over here. Now we need to return this. So we'll say return response entity dot status equals to HTTP status dot not found dot body equals to in the body I'll pass the message over here. Simple thing that I've done over here. It's nothing too complex over here. We created the method. That particular method is handling department not found exception over here. It's taking department not found exception as the input parameter plus the request as the input parameter. We are not doing anything with the request for now, but in case if we need anything from the request, we took over here. We created this error message object over here, and in this particular error message we are passing HTTP status not found and whatever the message it is, and we are returning this particular message wrapping around in the response entity. Simple over here. Now everything should work over here. Whenever the request comes to this particular department controller, and this particular department controller will throw that department not found exception, it will come around to this particular REST response entity exception handler. Because we added the controller advice, this particular controller will return the message as the response status, and this is the particular method that will handle that particular exception. If we have multiple exceptions, we can create the different methods for those particular types of different exceptions, and we can also use the same particular method for different kind of exceptions as well. So let's run this. Okay, here you can see that my application has started. Let's go to Insomnia, and earlier this was the error message that we were getting. Okay, now let's click on send and let's see what's happening. And here you can see that the entire error message is changed. Earlier it was having 500 internal server error, but that's not internal server error, that's data not found, right? So we just gave 404. You can give any of the status according to the requirement over here. So we give 404 over here, and we give the status as well, that not found, and the message as well, department not available. So this is how we can handle exceptions in Spring Boot for all our REST APIs. So now let's do one thing over here. Currently we are storing all our data in the H2 in-memory database. So by now I'm hoping that you are able to understand the entire flow of all the REST APIs that we have created, and you have gone through all the particular codes that we have created till now, and you are well versed with everything that is done. Now let's go up the notch and let's use the actual database. So currently what we'll be doing is we will convert our H2 database to use the MySQL database. So for that, what you have to do is you have to go and install the MySQL database in your machine. If you Google around also MySQL database download, you can just download that particular database. Just go to the MySQL downloads over here. Just download the particular database and install in your machine. I have installed MySQL Workbench over here. Just search for that as well, okay? If you search for MySQL Workbench, just download this particular thing in your machine and install it. I'll show you. Okay, I'm using MySQL Workbench. So let me just open this particular thing. You can use any of the database that you want, but we will go ahead with the MySQL over here. And this is the interface over here. You can log in over here. My database is working on port 3306. Okay, over here, and you can see that these are the default schemas available, default database available in my server. Now what we'll be doing is we need to change the entire properties, entire configuration. So if I go to the application.properties file, here you can see that these are the configurations that we have added for our H2 in-memory database. So that is database URL, username, password, and all those things. So we need to change it to use MySQL. So let's add the configuration. I will keep this particular configuration for you guys and I'll comment it so you can refer it. I'll add the new configurations over here. Okay. So let me just comment it out over here. Okay. And let me grab the new configurations. Here you can see that I just added the configuration over here. That is spring data source.url, the same over here that we have used. And instead of H2 in-memory database, I just added JDBC :MySQL //localhost :3306 /DCB app over here. Currently I don't have DCB app schema created, but we will create it. Okay. And my username is root, password is admin over here, and I changed the driver class name to use MySQL driver over here. And I just added jpa.show SQL equals to true. So whenever any of the query is executed, the query will be printed in the logs. So I just added that. If you don't add, the queries will not be printed over here. And here spring.jpa.hibernate.ddl auto update I have added. So whenever there is an update in the entities in our application, that particular entities will be updated in the database as well. So this is the configuration that I have added over here. The other thing that we have to do over here is to add the MySQL driver in our application. So earlier, if you have remembered, we added the H2 driver. If you go to the pom.xml file, if you scroll up over here, you can see that we added the H2 database over here. Now we need to add the MySQL. So let me grab that and add it. I am adding it over here after H2 only, so it's more visible. Here you can see that I just added MySQL connector for Java and group ID is MySQL. Let me just refresh my Maven changes. This is the one change that we did. The other change we did is in the properties file that we added this particular configuration and we commented out this H2 configuration now. That's it, no other change. Now your application will work on MySQL. The other thing that we have to do is we have to create this particular schema, right? So let's grab this name. Let's go to MySQL Workbench and let's create the new schema. I'll just do create schema. I'll give this particular name and I'll do apply the changes. And here you can see that this particular DCB app schema is created. There is no tables available, nothing available. Okay. Now let's go to the application and let's start our application. You can see that application is started. Now if I come here and if I refresh my database, here you can see that my department table is created and Hibernate sequence is also created over here, as we already added generate auto sequence, okay, in our entity. And you can see that there is no data available in my database. Now let's go to the Insomnia and let's save any of the departments over here. I'm saying IT department over here, IT Ahmedabad IT06. Let's save it. And if I come over here, you can see that that particular data is saved to my MySQL database over here. So pretty cool, right? We just added few of the configurations and my entire database has been changed now. So let me add a couple of more data over here. I'll do CE 07. I'll just add EEE. Electrical department is in Bangalore. EEE 01. You can see that 3 records I have created over here. If I do get over here, I'll be getting all the data. And if I go to the MySQL database and if I run this particular query, you can see that we are getting all the records over here. Now all our operations will work on this particular table. So that's how you'll be able to change your database as well. So do change this particular database, and if you are familiar with any of the other database also, try to use that particular database and add the configuration accordingly. The only thing that you have to take care in mind is whatever database that you are using, you have to use that particular driver for it and that particular driver name that you have to give in your application.properties file. So that's it. Now let's talk about the unit testing over here. Okay, every application should have or should do unit testing for that particular applications or for all the functionalities that we have. So here we will understand that what unit testing we have to do and how we can do all the unit testing. Unit testing you can do for your entire application. That's an integration testing that we call, that you will be testing your entire end-to-end flow. So whenever you hit any of the endpoint, how that particular endpoint is behaving, that you can test entirely. Okay, the other thing is you have to test all your different components as well. So suppose currently we have a repository layer, we have service layer, we have controller layer. So you can test all those 3 layers differently as well, or you can test all the 3 layers at the same time using the integration test as well. So here what we'll be doing is we will be testing all the 3 layers, that is repository layer, service layer and controller layer. So for this we'll be using the JUnit 5 over here and Mockit over here. So these are the 2 libraries that has been added to our Spring Boot application by default. So in the earlier starting of this particular tutorial, we saw that it was added the Spring Boot starter test dependencies over here in the pom.xml file. Let me just grab it again for you guys. Here you can see that this particular dependency was added, Spring Boot starter test. This particular test dependency have JUnit Jupyter, that is JUnit 5 and also Mockito over here. Okay, so we will be using this particular Mockito and JUnit to test all our components that we have created. Now let's understand the concept of mocking in unit testing. So wherever you see, you will be seeing that all the beans or all the different data will be mocked for doing the unit testing over here. Why mocking and why we have to do that? Okay, so consider you are testing the controller layer over here, right? So from that particular controller layer, you will be calling the service layer as well. So you'll be calling few of the methods for service layer as well. Now you are just testing the controller layer, not the service layer. Okay, so you are not considered about how the data has been flowed, how the service layer has been working also. You just want to test your controller layer, but your controller is still dependent on the functionalities or the methods available in the service layer. So what you can do is you can mock those particular things. You can just tell the system like, okay, whenever there is a call to this particular method or particular service layer, give me this thing directly. Okay, don't go to that particular service layer. So this is called a mocking. So you're just mocking the functionality available in that particular service layer. Let's take the example of a service layer. And in this particular service layer, you can see that there is a fetch department list method available, and which is sending the direct list over here. But I don't care about how service layer is working, okay, how service layer is getting me the data. I just want to test my controller layer. So whenever there is a call to this particular service layer for this particular method, I will just say that, okay, whenever there is a call to this particular service layer and this particular method, give me this object. Simple as it. So it applies for the other things as well. If you are working with the service layer and from that particular service layer, there is a repository layer call over here. Okay, so it's interacting with the database, but you don't want that. You're just considering to test your service layer. So for that repository layer also, you will be mocking all the data. So for that particular layer, you are not testing anything. And the same thing happens for your repository layer as well. When you are using your repository layer, ideally you don't want to save the data. You just want to mock that you saved the data. Okay, or you are getting the data from the database. Now let's implement unit testing in our application. So if you see over here, if you go to the project structure over here, and if you go down over here, you can see that we have a test folder and we have the same package information over here. Okay, that's the same package information that has been added for all our particular classes, for our main classes. Okay, and if you go over here, there is already one test case created, that is Spring Boot test, and for loading the context over here. We don't want it for now, so I'll just remove it because we'll be implementing our own test cases. So let's just remove it for now and let's focus on our own test cases. So now we will start with our service layer first. Okay, we'll go with the service layer, then we'll go with the repository layer, and then we'll go with the controller layer. Okay, and for everything we'll be doing the mocking over here. So the simplest way to create the test case file will be for each of the layers that we have. So for the department service, what we can do is just go to this particular department service, go to generate, and here you can see that you can create the test class over here from here itself. If you create the test class, you will get the lot of different options, like which particular test class you want to create. You can create for everything over here, or you can create for particular as well. And here you can see that it will be creating a class department service test in the same package itself over here. And here it's telling that you can use any of these particular generator methods as well also over here. Now you can also go ahead and create the package in your test folder, and you can create the class directly itself. But if you are using the IDE, we should use the IDE to do all our stuff. So let's just create from here as well. If you're using IntelliJ IDEA, you can create from here. And if you are using STS also, there is an option to create the test case from your main classes. So you can go with that as well. So let me just use this particular generate function and create the setup method. And that's it. We will create our other methods by our own. So let's go ahead and click on OK. And here you can see that department service test class is created. And if you go here in the test package over here, you can see that this particular service package was created and new file was created inside that particular service package. Now to tell the Spring Boot that this is a particular test class, okay, we need to annotate with using Spring Boot test over here. So now Spring Boot will know that this is a particular test class, and we can add all the things over here. Now here what we'll be doing is let's go to the service class, and we will implement this particular test case over here for this particular method, that is fetch department by name. So whenever we'll try to call any of the department over here, we should return the department by its name, whatever that we are providing over here. So let's implement it. We'll go to this particular class over here and let's create one method for test case. So I'll say public void, and always try to give the name of your test case methods very unique. So from that method name only, you will be able to identify what this particular test case is doing. Okay, though it's a long name, that's fine. Okay, so I'll say when valid department name, then department should found. It's a pretty long name, right? But that's fine. From here we'll be able to identify what this particular test case is doing. Now in this particular method, we need to find the name of the department, and we need to call that method as well from the department service. Okay, so we have to use the department service, so we need to auto wire that particular class. So we'll just use private department service over here, and we will use auto wire, and whatever the method that we create, we should annotate with @test. So this will be used as the test function over here. Now let me just define string department name equals to IT. Here I'll define, okay, department found equals to, we need to call department service over here, department service dot fetch department by name over here, and in this particular fetch department by name we need to pass department name. So this is a particular call that we created. What we have to do is we have to validate against it, okay, like whatever the name that I'm passing, okay, and whatever the object that I'm getting back, because this fetch department by name is returning the department object and it's saved in the found. So that particular department name in this particular found and this particular department name, if both are equal, then my test case is valid. So I'll just say assert equals, okay, and here assert equals will take two parameters, okay. First I'll pass department name and second I'll pass found dot get department name. Now this particular assert equals will match. If both are equal, then my test case is passed. If both are not equal, my test case is not passed. The other thing we need to always take care is we need to write the test cases for all the scenarios, all the positive scenarios, all the negative scenarios as well. Then only our entire code coverage will be completed. Now this is just the happy scenario that I'm doing, but we can always go with the negative scenario, like when invalid department name, then department should not return. So in those type of cases we should use assert not equals or assert throws, okay. So these are the different methods available. You can just check it out and we can validate against the data that we are sending back. Now the other thing we have to take care of is, if you go with this particular fetch department by name, this particular service is calling again the repository layer, right? So we already talked about, like, we just want to test our service layer. We are not considering about how that repository layer is working. So for this particular thing we need to mock it. So let's mock that particular layer. If you go to this particular fetch department by name, let's go to the implementation for it, and this particular fetch department by name is calling department repository and find by department name ignore case method over here, okay. So we need to mock this over here. So let's go to our test class and let's mock it. Now if you see this particular setup method that we already added, right, and here you can see that there's annotation before each. What it will do is this particular method will be called for each and every test case added to this particular class. So whenever we run this particular method over here, for that particular method this particular setup function will be called upon. There is another annotation that is before all. This particular, if you add this particular annotation to any of the class, that particular function will call before executing each and every test cases once. So if you have 5 test cases for this particular class, only one time that particular method will be called for executing all those particular 5 test cases. Before each will be called for each and every test cases. For if you have 5 test cases, for 5 times this particular method will be called. And there are also different annotations like after all and after each. Those type of annotations will is used to clear it out all the data that we have already created. So you can use all those particular things as well over here. So let me just use before each function over here. Now I need to mock it over here, okay. So let's mock the data. Now what we are mocking, department repository. So we need to create the object of it, private department repository, and we'll use mock bean over here, okay, from the Mockito. So this particular bean will be mocked. Now we need to tell this is mocked. Now when you call this particular method, what you want. So let's do that particular configuration. So first of all, what I need the department object that I want to return. So let's create that department object first. Department equals to, now here I can create the object using the constructor as well, or I can use the getter setters also to set all the values in my department. But in the starting of the video, when we were using the Lombok, when we were implementing the Lombok, at that time what we did, we added the @builder annotation to our department class. Not this one. If you go to the entity, you can see that we added the builder annotation over here. So that means this is providing the builder pattern. So what is builder pattern? Builder pattern is used when you have multiple properties available and you want to use the different sets of properties always to create the object. Suppose if you are creating the department object and if you have 10 properties, then with the help of 2 properties also you can create the object. With the help of 5 properties also you can create the object. So it's not defined, and based on that particular thing you can create the object. Now if you go with the simple approach to create the object using the constructor, then if you have 10 arguments, you have to pass all the 10 arguments. Or else what you have to do is you have to create the different constructor, lot of different constructor for all the different arguments available. Okay, that's really boring and really tedious. Not everyone likes, right? You should not do that. So it's a builder pattern. Whatever data you want, pass the data, and for that particular thing, that a particular object will be created. So we'll be using this over here. Okay, so we'll just get the demonstration also how we can use the builder pattern as well to create our objects. You can use any approach. So let's go to a test class again, and here I'll say department dot builder dot. Now we can set all the values over here. You can see that department name, department code, department ID, department address. So let's set all the values. I'll say department name as IT dot department address as Ahmedabad dot department code as IT06 dot department ID as 1L, one long value, dot build. So this particular object will be built. You can see that it is much neater to create the object this way, right? Now the main thing, when you call this particular fetch department by name from the repository layer, from the service layer to that particular repository layer, you need to pass this particular object over here. So what we'll do, we'll just say mockito dot when, means when you call department repository dot find department name ignore case. So when this particular method has been called, so it's IT over here, I'm defining that I want data for IT dot then return department. It's simple. So whenever you call this particular method, I want this particular department as the value back. Simple as it is. Okay, and here you can see that when this particular method will be called, for this particular method this setup will be called before that. So this particular mock bean and the mock method will be always available for calling over here. So now let's test this out. So if you run this over here, you can see that this particular test case is passed successfully. So this is the one thing that we did over here for our service layer test. So you can add all the different methods available over here. You can test everything over here. Now a couple of more things over here that I want to share is, if you see this is the particular name of your test case that has been shown over here, and it's the name of your method. It's nothing wrong with it. Okay, now you want to add something better for understanding when the report is created for your unit testing, you want some better name over here. Okay, so for that what you can do, you can add the display name over here annotation. Okay, this is the display name annotation, and in this you can pass get data based on valid department name, something you can give which is valid over here, and when there is a report generated with that particular name, you can identify what's happening. Let's run this again and let's see what's happening. And here you can see that this particular test case is running, but if you can see the name over here, it's get data based on valid department name. So it's more readable when the report is generated. But now suppose you have multiple test cases available and you want to disable any test case. Okay, then with @disabled annotation, you can disable that particular annotation over here. So this particular test case is disabled. So when the entire application, when entire test suite is running, this particular annotation with this particular method will be skipped. So this is all about the unit testing for your service layer. Now let's go ahead and do for the repository layer. Now testing the repository layer is little bit tricky over here, right? Because it's your database. You don't want to store any junk data when you are testing anything, right? That's the one thing over here, and that's very important thing. What we can get over here in Spring Boot is you can use @data.jp test annotation for testing our repository layer. What it does is it will, whenever you are trying to persist any data in the database, that particular data will persist into database at the time of that particular execution, and when that particular method is completed, that data will be flushed out. So that's the one advantage that we are getting when you're using the @GPA test over here. The other thing that I have seen is, or the other thing that you can implement is, you can run that entire unit testing in the different database itself. A testing database that you can create, either you can go with the in-memory database for testing that particular thing, or you can go with the containerized database. That's all the advanced topic over here, but let's focus on how we can do the testing for the repository layer with @data test over here. Okay, currently whatever we do over here, that will be persisted for the execution of that particular method, and after that particular execution of that method, that particular things will be deleted. So we'll check in our database also what's happening. We will try to add some data or try to get some data, and that particular data will be deleted. So let's do that. Let's create the test for the repository layer. The same way we did the last time, we'll go to the repository, department repository, and we will try to create the test over here. We'll use the setup method, and that's it. And here you can see that in the test folder over here, new repository package is created and your file is created. And this particular department repository test, we will annotate with @GPA test over here. So a couple of things we'll be needing over here. As we are doing the test for the department repository, we need the object for it. So we'll just do private department repository, and we will auto wire it. And the other thing we need is the entity manager. If you are using the entity manager, that's the default entity manager, that will still save and process the data. So there is a test entity manager available for the JUnit and Mockito. So we will use that. So we'll just say private test entity manager over here, and we will auto wire the same. So yeah, you can see that this particular test entity manager is part of JPA itself. Now in this particular example, what we will implement is find by ID. So currently if you go to the repository layer or in the JPA repository itself, there is a find by ID method available to get the data based on the ID itself. So we have to implement that. So let's go ahead and implement that. Now this particular layer, whatever the data that we have, that might not be having in the database. So we need to store that particular data. So let's do that. In the setup function, what we'll do, we'll create the department object. Department equals to department dot builder dot department name. I'll say complete new department. Let's say mechanical engineering department. Okay. Dot department code, I'll say mechanical engineering 011 dot department address, I'll say Delhi dot build over here. So this is the object that I want to persist. So what I'll do, we have entity manager, right? So we'll just use entity manager dot persist, and we'll pass department over here. So this particular data will be persist before I call my actual test case over here. So let's create the test case over here. So I'll just define public void when find by ID, then return department over here, and I'll annotate with @test over here. So this will be in the radar. Now I'll say department equals to department repository dot find by ID 1L dot get. Simple over here. And we will do assert equals department dot get department name should be equals to this one, mechanical engineering. So this is a simple thing over here. And if you go to the database, you have 3 records available, that is IT, CE and EEE over here. And here what we defined before each function means before calling each of the test case, we are saving that particular data into the database. It's mock, okay, and we are persisting it. So whenever the execution is completed, this data will be deleted. So let's run this test case. So here you can see that execution is completed, the test case is successful, and if you go and see the database, there is no new records available. You can see that we were able to test our repository layer without doing any changes to our database itself. So this is the basic approach to test our repository layer, but ideally I have seen many things like creating or running the entire unit testing for your repository layers while connected to the database in the entire different database, or running your test database in the different container, run it, do the testing, delete it. There are a lot of different approaches available. You can just go through the internet, you will find a lot of different approaches to do this kind of testing, and you can implement what is more feasible in your application. But ideally this is how you should be doing your unit testing for your repository layer. Now this is done. Now let's go ahead and implement the unit testing for our controller layer. Let's create the test class for our controller layer. Let's go to the controller. This is our department controller, and let's create the test class for this. I want this particular to be created for save department and fetch department by ID. Okay, let's do for these two things over here. Click on OK, and you can see that this particular two test cases are, two particular methods are already been added. We just have to do implementation over here. Now to test the controller layer is little bit different. The controller layer is been called when you hit any of the endpoints. So for here also we have to hit our endpoints, and we will see how that particular endpoint is behaving. So for that we'll be using the web mock MVC. So let's go ahead and do that. Instead of doing the annotation like Spring Boot test or Data JPA test, those were specific to what it was doing, we added according to the need. Here this is our controller, so we need to test our endpoints, so we need to create the context itself. Okay, so we can do @web MVC test, and I want to test my department controller, so I'll just define it over here. So for this particular class only my mock context will be created and we can use it. Now as we are using the endpoint, we have to use the web MVC over here, right? We are using the web MVC. We need to mock that particular MVC. So what we can do, private mock MVC, and here we will do @AutoWired over here. Now the other thing that we did in the service layer itself, like mocking the bean. So from the service layer we were calling the repository layer. So that particular repository layer we mocked it. So from the controller layer we are calling the service layer. So we need to mock service layer. So let's do private department service, and we will use mock bean. Now let's create one of the department object as well. I just want private department object as well. So this particular department object I will create from here. So let me just do department equals to department.builder dot department address as Ahmedabad dot department code as IT06 dot department name as IT, and dot department ID as 1L, that is department ID as 1, and dot build over here. So this is the object that I have created. Now I will be using this particular object in my test cases over here. So let's go ahead and implement that. So we'll first implement the save department test over here. Now for this particular save department, I'll be calling the save department method of a service layer. Okay, so for that we need to use the mock bean over here. Okay, we need to mock it, and we need to call that particular method. Like whenever there is an input for this, I want output for this. So if you go to this service layer itself, and for the save method, here you can see that for the save method, it's taking entire department as the input parameter and entire department as the output parameter. So we need to do that as well. So let's go to the department controller test, and here we need to do that. So I just created the output object. Okay, this will be the output. So let me just create the input also. So let me just copy paste it, and here I'll say department input department, and for the input department we won't be having the department ID. So this is my general object over here. Now we need to mock it. So I'll just say mockito dot when there is a call for department service dot save department, this particular save department will take input, this one, input department dot, then return department over here. So this department is this particular department that we created, which will be persisted data. Okay, when the data is persisted, we'll be having this department ID added. So you can see that that's the difference over here in my input department and output department. Now we need to call the endpoint over here. Okay, so what we'll be doing is we have to do mock MVC dot perform action. So what I want to perform is the post request. So for that, what I need to do is mock MVC request builders dot post method over here. Okay, and inside this post I need to pass my URL. Dot content type would be media type dot application dot JSON dot content. Now this particular content would be your JSON data. So let me just add that data. I'll go to the Postman. I have to update this data. So let me just go ahead and first of all update the data over here. Ahmedabad IT06 and IT over here. So let me just copy it and paste it over here, and after that, and expect what I'm expecting out of it. Okay, I'm expecting mock MVC result matchers dot status dot is okay. So I should be getting the 200 okay result over here. Okay, and here you can see that I need to add the exception to method signature. Let's add it, and this is done. Now here you can see that this particular mock MVC, whatever the operation that you want to perform, it's correct. Whatever I'm adding over here, I need to pass the post URL as well. So my URL is, let me go to the department controller, and my URL is /departments over here. Okay, so let me add /departments over here. So this is the final method. Now couple of more things that we can clear it out over here. You can see that the name of this particular static classes are too big over here. Okay, so let's do the static import for this, so it's more cleaner. Okay, so I'll just do Alt or enter over here, and here you can see that's add on demand static import for this, lot more cleaner. Okay, let's do for this as well. You can see that it's a lot more cleaner over here. So this is a particular method that has been created. Now let's test this out. Okay, what it will do, it will try to hit this /department service, and whatever the data it is, input parameter, this is the one, and output it is testing that all the request is okay over here. And whenever there is a call for this particular department service dot save department, this is the mock that we have done over here. So let's run this. And here you can see that save department is successful. No extra data has been saved. Everything is mock. Now let's implement the another method as well, that is fetch department by ID. So for this also, what we'll be doing is we'll be using the mockito dot when, and we'll say department service dot fetch department by ID. Here I'll pass 1L dot, then return, then run department object over here. Okay, and add exception to the method signature. Okay, simple. Now here we need to perform the get operation. So here we did the post operation, here we'll do get operation. So we'll just say mock MVC dot perform. We can do get, we pass the URL over here, and URL would be the same. Let me copy paste it. /1 I'll be passing. Okay, because the return object is this one and the department ID is 1, so I want this particular object back. Dot content type would be media type dot application JSON dot, and expect status dot is okay over here. And let's do one more thing, and expect, and here let's check the JSON values as well. So whatever the JSON data it is should match with the data that we have over here. Same thing over here. Okay, it's simple. I'm just giving you the idea so how you can do the testing as well. Okay, how you can match all these values. So whatever the JSON data it would be, I'll say dollar dot the name of the value. So if I go to the department entity, I'll match with the department name I have. So let me copy paste it, go to the controller, which should be dollar. Okay, dot value to department dot get department name. Okay, simple. I'm matching that it should be okay result, and the department name that I'm getting should match with the JSON's department name. Okay, so let me run this again, and here you can see that it's successful. Okay, so you can see that we were able to implement the unit test cases for all the different layers, and we also saw how we can add the unit testing for the different layers based on the different functionalities, how to handle the controller layer, how to handle the service layer, and how to do the repository layer as well. Now let's see how to add the configurations in your configuration property files and how we can use that in our application. So suppose considering any of the data that you want to add in your configuration files, okay, for any reasons, add that in your configuration files and how we can use it. So let's go to the property files over here. You can see that we are adding all those particular configurations over here. So how Spring Boot is using all this configuration from this particular configuration files, and suppose if you want to add your own configuration, how we can use it. So let's check how we can do it over here. Okay, so let's see, I added any of the key value pair. So I'll just say sum.config and let's give the value as some configuration data. So this is just a key value pair that I've added and I want to use this in our application. So let's use it. Let's do it simple over here. So we had a hello controller over here, okay, and from here we were passing this particular message over here. Okay, this was hard coded. So let's take this particular message and put it in this particular file over here, and I'll just say welcome dot message over here. Simple thing that I'm doing. So whenever you want to change this particular welcome message, you don't have to change the code, just change the property file and you're good to go. So this kind of configuration generally we should be adding. Now let's go to the controller layer, hello controller, and I want to send it back from here. So what we can do is, let's create one of the property, private string welcome message over here, and I want to use that particular property from that particular configuration file. So I can use @value over here, and in this particular value annotation I need to pass that particular. So let me just copy this value from here, that is welcome message over here. Okay, and if I go to this controller, I can give using dollar braces and welcome.message over here. So this particular value will be fetched from the application.property file and will be attached to this particular variable, and we can pass this variable return welcome message. So you can see that we removed the hard-coded value and we added in the property file. So we can directly get the values from there. So you can see that it's very easy. Now we are directly getting this value as we added in the application.property file. That's the default file available. If you are adding the values in the different files, then you can add the property source values over here, like from which particular property resources you want to fetch that particular values. That also you can define using the @properties resource annotations over here. So let's run this application and see how it's behaving. Okay, let me run this and we'll call this particular API. Let's run this application and we'll call this particular endpoint. That's the default endpoint over here. Okay, you can see that application is started. Let's go to the browser. Let's hit localhost 8082 / and here you can see that we are getting welcome to daily code buffer. This value we are getting from the application.property files. Okay, so this way you can add any of the configuration values in your properties file, and using the @value you can get all the values back. Now Spring Boot has a support for YAML configuration file as well. So currently you see that we added all the properties in our application.properties file. That's the properties file defaultly added or defaultly created from the Spring Boot application. There is a YAML file also created, either application.yaml file or application.yml file, and in that also all the configurations that you can add. That's a default supported by Spring Boot application. Now why we need a YAML file? Why we should be opting for a YAML file? The first thing is YAML file is a more human readable format, and the other thing is it reduces the duplicate values over here. So currently you see that the database values that we have provided over here, that is spring.datasource.url, spring.datasource.username, you can see that half of the part of this particular key is been repeated. So that is not a good way to do our configurations. What YAML provides us is a human readable format where we can remove the redundant part and we can give the configuration in a proper independent format. So we'll see how we can do that, but I can say that it's a really good format and it's widely adopted as well. So if you see any of the other technologies as well, most of the technologies will be using the YAML configuration itself. Either you go for Docker, Kubernetes, OpenShift, or the AWS configurations, anything. If you see currently, YAML is the way to go. So I prefer YAML, and that's why I have included this particular topic, that how we can go ahead with the YAML configuration in Spring Boot and how we can create or how we can change our current configuration also to Spring Boot. So let's see that. So what we can do over here is, at the same point where our application.properties were created, here we can create our application.yaml file. Before that, there are different plugins available to convert your properties file to your YAML configuration as well. There are plugins available in IntelliJ IDEA also, Eclipse also, in VS Code also. So if you want to convert, you can use that as well. There are different online tools available where you give your properties and it will convert that to your YAML configuration. So you can choose any of the one, whichever is comfortable for you, you can choose. Here I'll show you how we create it. Okay, so let me just create the application.yml file. I'll create a new file and I'll say application.yml. You can use YAML as an extension or YML extension, whatever you like. So currently, if you see, to give the server port over here, it's like server.port equals to 8082. But in the application.yml file, you can give server colon port colon 8082. So this is the configuration, and the indentation is very important over here. So it has to be the correct indentation. Okay, now let's go ahead and copy paste this entire configuration. Let's go to any of the online tool available. We'll say properties to YAML. Let's use any of the tool. Let's add my properties, convert, and this is my YAML configuration. Let's copy paste and add it over here. Okay, and let me comment everything over here. We are not using the application.properties file now. Commented everything. We'll be using application.yaml. Here you can see that it's much more readable. Here we can identify server.port, and from here you can see that there is no redundant text available. Okay, this is spring.datasource.driver class name, spring.datasource.password, spring.datasource.url, spring.datasource.username. The indentation is very important, and for here spring.jpa.hibernate, .ddl auto, spring.jpa.showsql, and this is the welcome message, whatever we added over here. So this way we can add the configuration in YAML file. And so let's run this. Okay, so let me run the application. Here you can see that my application is started. Okay, now it will be getting the data from this application.yml file. If I go ahead and hit this particular URL, you can see that everything is working the same way. Now let's see what is profile in Spring Boot. Now consider we have an application, like consider this application. Okay, this is a application where we are saving the department. So it's a department service that we created. Now this application has to be executed or has to be deployed in our dev server, QA server, stage server, production server for all the different environments. So for all those particular different environments, we will be using the different configuration properties. Let's take the example of the database only. So we'll be having the different database. So the database configuration properties that we added over here has to be different for all the environments. So how we can achieve that in Spring? Using the profiles over here. So what we'll do, we'll create the different profiles for our dev, QA, prod servers, and we will add the different configurations for it. And when we deploy our application, we will give Spring that deploy my application using this particular profile. Let's create the profiles in Spring over here. So now as we have created the YAML configuration, we'll go ahead and create the configuration in YAML itself. Now in the YAML, what we can do, we can create the multiple documents in a single file itself. So we will be going ahead with that particular approach. Otherwise, what we can do is we can create the different configuration files for the different environment. Suppose your profile name is dev, then you can create the application-dev.yml file. If your profile name is QA, then you can create application-qa.yml. For the prod, you can create application-prod.yml file. Else, you can add all the configuration in a multi-document in a single file itself, that is application.yml file. So we'll be going ahead with that particular approach. So let's add the configuration for that. Let me create the new document. We can create new document using 3 hyphens over here. So this particular part is one document, the below part is another document. Now in this Spring, we can define Spring profiles over here, and here I'll define this particular profile is dev over here. So for my Spring dev profile, this is my database details and everything. So let me create multiple profiles over here. Okay, I'll say that this is my QA profile. And I'll say this is my prod profile over here. And I'll say my prod profile is using DCB app-prod database. My QA is using DCB app-QA database. And this is the using same database over here. Now ideally all these configurations will be different. Here also we added the database different over here. Okay. Now how to tell Spring which profile to run. So for that we need to give default active profile over here. So let's give that. So we can add Spring profiles active over here, and let's say my active profile is QA. So currently my application should be running with this profile over here. So that means I should be having this DCB app-QA database over here, but I don't have currently. Okay, I have only one database. So if I start this particular application, it will fail. Okay, let me just restart the application and it will fail. And if you see over here you can see that application failed to start. Okay, but if you go to the top in the logs, here you can see that the following profiles are active, that is QA. So my application started using the QA profile, but the database was not available, so it failed. So let's create this particular database. Okay, so I'll just create QA and prod both. So let me create schema, that is DCB app QA. And let me create the prod schema as well. Okay, so let's do this as well. Okay, now you can see that DCB app one schema, DCB app-prod and DCB-QA. So 3 database we created for 3 different profiles over here. And currently you can see that for the DCB app QA there is nothing available, no tables available. Okay, and let's start this application. And here you can see that my application will be again started on the QA profile, and application started as well. And here if you come over here, if you refresh it, you can see that the table was created in this particular database. And if I try to execute the query, you can see that there is no data available. And if I save the data, you can see that the data has been saved in this particular QA database. So my application is running for QA now. Okay, so it's running with QA profile. So we created multiple profiles and we are running with multiple profiles. But this is not how you will be deploying your applications in production, right? You will be creating your jar files and you will be deploying it. So let's see how we can do that as well. So in the earlier videos also we saw that how to run our Spring Boot application from the IDE as well and from the command as well. Now let's see how to deploy, actually how the application will be deployed in production environment. So for that we have to create our applications. Okay, we have to create our jar files. So let's go ahead and do that. Ideally we will be giving one specific versions to our application. So for that let's go to the pom.xml file, and if you go to the versions over here, you can see that my version is 0.0.1 snapshot, which is not correct. Let's say we are deploying the application with version 1 over here. Okay, so let's say we will give 1.0.0. This is the first version that we are deploying, okay, in production. So we give this version. So my jar file will be created using this particular version. So let's go to the terminal, okay, and let's create the jar file. So with the mvn clean install command, we will be creating our jar files. Clean will clean the target directory and install will create the package. There is a package goal as well that will create the package. There is a deploy goal as well that will create the package and deploy to the maven repository. So you can choose any of the goals available according to requirement. So this will execute all our test cases as well. Okay, you can see that it started executing all our test cases also. So until and unless all the test cases are executed, our build won't be generated. So that means all our unit testing is successful and we are ready to go ahead with the deployment. So here you can see that we added 4 test cases and everything is successful, and after that our build was created. And if you go inside the target directory and if you do this one here, you can see that this is my application, that is Spring Boot tutorial -1.0.0.jar over here. Now we can deploy it. We will be able to deploy this directly because as we are using Spring Boot, we don't need any servers. Embedded server is inbuilt in our particular jar file, so that entire thing will deploy to that particular embedded server. So how we will run this is using java-jar command. Okay, and after that we have to give which particular jar file that we want to run. So I want to run Spring Boot tutorial -1.0.0.jar file, and after that for which particular profile I want to run this particular application. So I want to run for prod. Okay, so let's do that. Otherwise, if I don't pass any of the information over here, by default it will run with the QA profile, because we have given over here that my default profile is QA, active profile is QA over here. So that will run with the QA profile. But if I want to override that value, I want to run this in my production with the production profile, and I can override this value using the arguments over here. So let's pass the argument, that is spring dot profiles dot active equals to prod over here. So this is the argument that I'm passing and overriding the values over here. So let's run this, and here you can see that my application has started, and here you can see that my following profile is active prod. Okay, so my application is started with the prod profile now. And if I go over here to the MySQL database, and if I go to the prod over here, you can see that the table is created for this prod. And if I see if there is any record, there are no records available. So let's add the records to this also. If I execute this save department API, this particular department is saved, and if I execute the query, you can see that I'm getting my data in prod. So this way I will be able to deploy my Spring Boot application with different profiles. So this is how you will be differentiate the different properties and different properties for the different profiles, and you can leverage this to deploy your applications in different environments. So currently if you see, we just added only database source and the welcome message over here. We can do this for all the properties over here. So just go around and explore this profile as well. Now let's see what is Spring Boot Actuator. Now whenever we deploy any of our application into any of the environment, that is production environment, we have to monitor our application, how that particular application is performing. Is the application healthy? What are the different beans created? What are the different objects created? What's the memory utilization of our application? All this we want to monitor. So Spring Boot Actuator provides us this particular functionality to manage our application health and all those different matrices. So let's see how we can do it. So for this we have to add the dependency, that is Spring Boot Actuator. So let's go to the pom.xml file and let's add the dependency. So this is my pom.xml file. Let's go ahead and add the dependency for actuator. We'll go to the dependency, and here I'll add Spring Boot starter actuator dependency. And if you go to this particular file, what's included is, you can see that Spring Boot actuator auto configuration has been added. So all the auto configuration has been added by default, and it is using Micrometer core to do all the matrices over here. So after adding this dependency, we have implemented the configuration to manage our application with the default configuration. So let's see what we have defaultly configured. So let's run this application and let's see what default we have. So here you can see that our application is started. Let's go to the browser, and here you can see that our application is running. So to go to the help points, actuator help points, if you go to the console logs as well, here you can see that there are 2 endpoints has been exposed at the path /actuator. So let's see this path. So I'll add this particular path, and here you can see that there are 2 endpoints that is been added to here, that is health over here and info over here. So let's see that. If I open the health over here, you can see that we are getting status is up. So this particular health endpoint will give what's the status of our application, what's the health of our application. So currently the status is up, so my application is healthy. And now let's see what info is giving. Currently nothing, okay, but the endpoints are available. Now there are a lot more endpoints available that are by default disabled because it's an auto configuration done by Spring Boot. You can enable it whatever you want and you can disable it whichever you don't want. So by default Spring Boot thought, okay, these two are important, so they enabled those things. The rest of the things are disabled. Now let's see how to enable it. Okay, so let's go to the application. So now let's enable all the different endpoints over here. So for this we need to go to the application.yaml file, and you can see that my default profile is QA. Let's add in the QA for now. Okay, so I'm just adding this particular configuration, that is management.endpoints.web.exposure include all. So enable all the endpoints. You can expose all the endpoints for the JMX as well. So there are two types of options available for the web and JMX. You can choose either of the one. Currently we are just going for the web just for the simplicity to see how the actuator is working, but there are a lot more things that you can do. So this has been enabled now. Okay, now let's run the application and see what all things are available. So here you can see that my application started, and if I go to this particular logs, you can see that there are 13 endpoints exposed beneath the /actuator over here. So let's go ahead and see that. So let me just refresh it, and here you can see that there are 13 endpoints available. Okay, so you can see that beans available, cache available, health, info, conditions, config properties, environment variables, loggers, head dump, thread dump, metrics, what are the scheduled tasks, mappings, everything is available. You can see all those particular values. So let's see the different values. Let's see the environments. So here you can see that these are the different environment values available. Okay, some of these values are default set by the Spring Boot auto configuration, and if you add new values, that will be added, that you all can see over here. All these particular endpoints has to be secured because no one should be able to access this endpoint, so it should be behind your Spring security. So that also you should implement. All these particular endpoints should be behind your Spring security. Currently we are not doing anything over here, so let's see all the values. So this is the environment. Let's go ahead and see the config properties. Here you can see that these are the different configuration properties added, and here you can see that it will also show from where this particular config properties has been added. So we have created the application.yaml file, and at this particular line number, this particular value has been added, that is show SQL. Here you can see that exposure endpoint, this is coming from application.yaml file from this file, and all the other values will be added by the default configurations as well. Let's see the beans as well. Here you can see that these are the different beans added to our application. Okay, let's see if there is any cache. There is no cache manager added. Okay, let's see the loggers. Okay, you can see that the log levels for each and everything. So there are a lot of endpoints available. You can get the thread dump as well. Okay, all these values available. Now all these values you can expose over the JMX also, and you can monitor everything using the JMX as well. So there is a Spring admin available. You can use that Spring admin to utilize all these APIs and create the entire dashboard as well. So there are a lot more things and a lot of features available within the Spring framework as well to utilize everything. So just go through the documentation and you will get a lot more idea about Spring Actuator as well. Now if you want to override any of the APIs available, that also we can do. Consider info is not providing a lot of details over here. You can add details in the info endpoint as well. And if you want, you can create your new endpoint as well, and you can expose over here. So let's see how we can do it. So let's go to the application and let's create the endpoint. So in my application, let's create the package over here that will say config, because we are adding the configuration. And let's say we are creating one of the class that is feature endpoint. So we are just creating one of the management endpoints from the actuator that will say which all the features are enabled for this particular application. So from that we can directly identify which features are there in this particular environment, which features are there in this particular environment. We can get the idea. So let's create the endpoint for that. So I'll just say feature endpoint class. I will annotate this particular class with @component. So this is in the Springs radar now. Now to create this particular feature endpoint as the endpoint for the actuator, we have to annotate with @endpoint. Here you can see that this particular endpoint annotation is the part of Spring Boot actuate. So let's create the endpoint over here and we can pass the ID over here. ID equals to, let's say, features. Now let's create this particular functionality. What we'll do, we will create one map over here that will have the data like which particular feature is enabled or disabled. So let's do that. We'll just do private final map. Map is of type string, which particular feature it is, and that particular feature details that we can add over here. Okay, so for that, let's create the feature class, and for this I'll say features map. Okay, equals to new, let's say concurrent hash map. Okay, so this particular object is created. Let's create this feature inner class. Okay, so we just created the inner class over here and let's make it static. Inside this, let's create the different properties. We can create different properties and we can show all the properties over here. For now, let's create only single property that says it's enabled or disabled, and I'll say here private boolean is enabled. Okay, this is one property and I want getter setters for this property, so I'll just say @data using Lombok to add the getter setters. I want no arg constructor, I want all args constructor simply. Okay, so I just added all these particular things so I can add all the data in this feature map. Now let's add this particular map using the constructor. So let me just create the constructor over here, and inside this constructor what I'll do, I'll say feature map dot put, and I'll say department feature. Okay, I have a department implemented, so let's say department feature is implemented, and here I'll say new feature, we'll say true. We just added is enabled field as a true. This particular feature is implemented. Okay, so now let's add multiple values. Let's say that after department we will be creating the user service as well to save the user, but currently that is not implemented. We will be adding the authentication as well, but currently that is not implemented. So we just added all these particular values. Now let's create the endpoints. So for the endpoints we need to create the method. So we will just say public, and it will return the map, and this map will be of string and feature. Okay, so what we are doing is we are trying to send this particular feature map back when it calls features. Okay, we'll say return feature map. So what we are doing is we created one of the endpoint that is features, and that will send back the list of features available inside this particular application. So this is the one endpoint that we added. Now this particular features will be the get operation. Okay, so we want to read the data, so for that we need to add read operation over here. We can create the write operation also, and we can create the delete operation also. Delete operation for deleting, write operation for saving the data. Now let's create one more endpoint to get the details of that particular feature that we are selecting. So let's create that as well. We'll say public, which will return feature object, and we'll say this is a feature endpoint, and which will return feature map dot get whatever key you pass. So for that we need to take input also. So we'll just say we'll be taking input as a feature name over here, and this particular feature name we have to pass in this particular get method. Now this is also read operation. Okay, we are getting the data, but one thing where we have to add over here is that this particular feature name is a selector, so we need to select that particular value and pass over here. So for this there is a selector annotation available. So we created the two endpoints over here that are get operations to get the list of features and to get the features in our application. Now let's run this and let's see what's happening. Okay, let's run the application. And here you can see that my application started, and now here you can see that earlier there were 13 endpoints. Now you can see that there are 14 endpoints because we created the new endpoint over here. Okay, so let's go ahead and refresh my actuator over here, and here you can see that this is the features that we added new over here. So let's go to this features endpoint over here, and here you can see that these are the features that we added, right? Department feature, user feature, authentication feature, and we also told that okay, this is true, false, false, and these are the different attributes that we can add. Now there was also one more endpoint that we created, that is feature/selector. So if you pass any of the feature name, that will be called. So for this particular features, if I pass department feature over here, let's select this department, and if I pass this particular department value, it will get the details of that particular department. So currently we have added only one attribute, so it's showing the one attribute. But if we have multiple, if you want to describe what this particular feature is, we can add all the details and we can show it over here. So this is how we can implement the different actuator endpoints, and we can utilize this particular functionality. Now suppose there are a lot more endpoints available, and if you want to exclude that, if you want to not expose those particular values, so let's see how we can do that. So currently if you see that there are environments and beans available that shows all the information about our application, like what are the different environments added, what are the different beans or objects created. So let's hide those things. So for that, what we need to do is we will go to our application.yaml file. Let's go to the application.yaml, and these are the management endpoints that we have exposed. So here you can see that we included everything. Now we can exclude also. So here I can say exclude environment endpoint and exclude beans endpoint. I need to give in quotes. So I'm excluding these two endpoints over here. So let's run this application again. And here you can see that out of 14, only 12 endpoints are available. These two endpoints are not available. And if I go ahead and refresh my application, you won't be able to find any beans over here. Okay, or not environment as well. So this way we can disable the endpoints as well from the actuator. So this was all about the Spring Boot over here. Okay, we cover a lot of topics over here. So if you are aware about all these particular things, then you are good to go to create the production grade application. So there are a lot of different things that we covered over here. We saw the different annotations available in the Spring Boot and how we can use those particular annotations. We saw how to create the different endpoints available, and we also saw how to save all those particular data in the database. We also saw how to use multiple database as well to change the database and all those particular things. We also saw how to change the configuration using the configuration.properties files. We also saw how to do the unit testing of all our components that we created. We did controller testing, service testing, repository testing as well. We did the profiles, how to deploy our applications in different environments using the different profiles as well. We also see how different actuator endpoints are available. We also converted our properties to the YAML configuration that is widely being used. So this is a lot of things that we covered, and if you know all these things, you will be a really good Spring Boot developer, and you can always learn advanced topic going through the documentation for this. Now if you have already gone through the Spring Boot tutorial, then it's probably like you need to understand in depth about the Spring Data JPA. Now in that particular tutorial, we covered the brief about the Spring Data JPA and we created few of the APIs. In this tutorial, we are going to deep dive about all the topics available in Spring Data JPA. Now what we are going to cover in this particular tutorial, we are going to cover how to map a particular class to a particular database table, how a relationship is been created using the particular one-to-one mapping, one-to-many mapping, many-to-one mapping, and many-to-many mappings. So we'll go through all the different types of mapping relationships available in JPA. We'll also understand what is JPA and why we need JPA. And we are also going to see a different annotations available that will help us to create more robust applications, like how we can add the native queries, how we can add the GPQL queries, how we can add the embedded classes in our entities. All those different things we are going to see over here. We are also going to see how we can create the unidirectional and bidirectional relationships. We are also going to see how we can add different constraints and how we can match our entity with the exact table that we have in our database. So there is a lot of things that we have to cover in this particular tutorial. So I suggest you to do practice while I'm going through the tutorial. Now when we are working with the Java applications and we have to connect to the database, what we do is we use JDBC. So JDBC is an API provided by Java, so we can connect with the database. Now the problem here is Java works on the concepts of objects and classes, and database works in the concepts of tables that will be having rows and columns. Now how to match together? Now in the traditional way, if you're using the JDBC, what we'll be doing is we will be getting the data from the database that will be in the table. We are getting all the records and we are converting them in the objects or the classes that we have. So that's the conversion that we are doing. But ideally we should not be doing those conversions. There has to be a system where it defines that this particular class or objects represents this particular table in the database. Now for these reasons, there are different frameworks available that gives us the functionality that is called ORM, that is Object Relationship Mapping. Now what ORM is? ORM defines whatever the classes or objects is defined in your system, in your Java application, that will represent the table in your database. Now the frameworks like Hibernate, iBatis provides this type of functionalities. Now what happens is Hibernate has its own implementation of ORM, how the different functionalities, how the different sessions, objects, and how it is behaving and how it is interacting with the database is different compared to how it's in the iBatis, because iBatis will also have its own implementation. If there is any other framework, those particular frameworks will also have its own implementation. Now when this type of different implementations are there, when we have to change any of the implementation framework, like if I want to change from Hibernate to iBatis, then it's very difficult. So whatever the specification has been used by Hibernate doesn't necessarily to be used the same in the iBatis. So what the Java people thought of, let's create the standard specification, and those standard specification will be used by all the third-party API providers or ORM providers, and whenever we have to switch between those providers, it's very easy for the application developers. So suppose Java provides a JPA specification, that's a Java Persistent API specification provided by Java, and all the framework providers like Hibernate, iBatis, and all the different available will be using those specifications and creating their implementation of ORM. So what happens is, if you are using the JPA and if you want to convert from Hibernate to iBatis or from iBatis to Hibernate, then you can convert it very easily. Now the one important thing is what Java provides is just a specification. So you have to go ahead with the implementation provider. So you cannot tell that, okay, I'm just going with the JPA. If you're going with the JPA, you must be using Hibernate or iBatis or any of the framework, the ORM provider, because JPA is just a specification and you are using that specification via any of the framework provider or any of the third party provider ORM providers. So this way JPA specification has been implemented and the application developers implement those JPA using any of the third-party framework availables, and switching between them is very easy. So this is all about why JPA was introduced and how Hibernate and all those different framework uses JPA and how we can change whenever we need to change in our application. So now let's see what we are going to build it today. We are going to build a small relationship over here. I'll show you the example. You can see that this is the class diagram that I have prepared, and we are going to build this particular class diagram over here using the Spring Data JPA. Now, what all the things are over here? You can see that there is a student class, there is a guardian class, course, teacher, and course material over here. Now, all these different classes are represented by the tables in the database. So we are going to create the tables based on the classes that we have defined over here. Now here you can see that all these particular different classes defines a particular relationship with each other. So we are going to see what those particular relationships are and how we can define the relationship in the entity so that a particular represented tables are created in the database, and how we can store those data. So here you can see that we have a student class and we have few of the attributes available like student ID, first name, last name, email ID. This particular class have its name and have its different properties available. So that particular class, how it's represented in the database is that particular class name will be represented by the table name. Okay, and all the properties that are there like student ID, first name, last name, email ID, all those particular attributes are represented by the different columns. So there will be different columns, and for all the columns we will be inserting the records over there. All those particular records will be rows created. right? So this is just a simple representation how an object will be represented in a database table. Now this particular student will have a guardian. Who is the guardian for that particular student? So that relationship, how we want to define, we will be defining in our system. Now there is a one-to-many relationship between student and courses, because one student can opt for many courses available. Now there is a one-to-one relationship between course and course material. For every course there will be a one course material object, and without the course you cannot create the course material as well. So there is a one-to-one relationship between course material and course available. Now between teacher and courses there is a one-to-many or many-to-one relationship, you can say, because one teacher can teach multiple courses, and on the other hand you can say that multiple courses can be taught by one of the teacher. Okay, so there will be one-to-many relationship or many-to-one relationship. How you can define in the system, that will represent what you are going with, many-to-one or one-to-many. Now between student and courses, multiple students can opt for multiple courses. So it's a many-to-many relationship. Like many students will be opting for many courses. So this is just the overview of all the different classes that we are going to create and how they are related with each other. So when we create the application, we'll be creating all these particular classes and we will define the relationships as well. Now let's go ahead and create one Spring Boot application where we will define the Spring Data JPA and we will connect to our database. So let's go to the Spring Initializer over here. Okay, start.spring.io, and let's define the properties over here. I'll define group as com.daily code buffer, artifact as Spring Data JPA tutorial, name as Spring Data JPA tutorial, and package name I'll define as spring.data.jpa tutorial. Okay, so this is just a simple package name that I have defined over here. I'll be using the packaging as jar file, Java version as 11, and let's add the dependencies. As we are going with JPA, first thing we'll add is Spring Data JPA. I'll add the Lombok dependency, okay, to reduce our boilerplate code, and I'm going to use the MySQL database, so I'm going to add the MySQL driver, and let's add the Spring Web dependency as well. So suppose if you want to create the REST APIs out of it, you can create the REST APIs as well. Okay, so these are the 4 dependencies I have added over here. So let's generate the project and open in our IDE. So I'll be using IntelliJ IDEA. You can use any IDE of your preference. Okay, let me open IntelliJ IDEA. Open project and Spring Data JPA tutorial. So it's resolving the dependencies. Let's wait for a second. Okay, so this is my project over here. Let's open the pom.xml file, and here you can see that we added Spring Data JPA, Spring Starter Web, and if you go to Spring Starter Data JPA, so this particular Spring Data JPA is using Hibernate as its default implementation over here. Okay, so we are using JPA with the Hibernate implementation. Okay, if you want to change it, we can change it as well. Okay, let's go with the default for now. Okay, so this is our pom.xml file. All the details are there. Now what we have to do over here, let's open the MySQL as well. Okay, I'm using MySQL Workbench 8.0 CE. So this is our database now. Here you can see that we have only default databases available. So what we will be doing is we will be creating one of the database over here, and we will be providing all this particular configuration details in our Spring Boot application, so that Spring Boot application can connect to this particular database. So let me go ahead and create the database over here. I'll just go ahead and create schema. I'll say SchoolDB over here. Apply the changes, finish, and here you can see that SchoolDB is created and there is nothing inside this particular schema. Okay. Now what we have to do is, for our Spring Boot application to connect to this particular database, we have to give the properties in our application.properties file. So let's go to the src main resources application.properties, and here we can define the configuration. Okay, so let's add those configurations. Now here you can see that I have just copy pasted the configurations over here, and this is very simple. Here you can see that I have just added spring.datasource.url, the URL of your database, the username and password of your database, okay, and which particular driver that you are using. As we have added MySQL driver and I'm using MySQL database, I have just defined that I'm using com.mysql.jdbc.driver over here, and I just defined spring.data jpa.showSQL as true. So whenever we are doing any operation, all those particular queries will be printed in the logs. Now this particular thing, spring.jpa.hibernate.ddl auto. This particular thing I have defined as update. Now this particular thing defines whatever changes that you do in your application, like whatever entities and whatever classes that you define, those particular thing, how it will interact with the database, that has been defined by this DDL auto. So suppose currently if you see that I have added update, so whatever the updates I do in my entities or any of the objects that I'm creating, those updates will be applied to my database directly. So suppose what will happen is, if you have 3 fields available in your database and 3 particular available in your classes as well, and if you add 2 new, that 2 new changes will be applied to your database as well. So there are different properties available for this. Okay, you can go and check that out as well. It is advisable not to use this particular property in the production application, because generally when you are working with the production applications, there will be a different team available that will be handling your database operations, and different scripts you need to create to do all the changes regarding your database, and your application will be different. So this particular thing that I have added over here, just to make sure that whatever changes that we are doing in our application, that is directly been reflected, and you can directly see what's happening in the database when we do any changes in our entities over here. So for that purpose only I have added over here, but whenever you're going with the production, you should not use this. It's not advisable. And whatever particular database objects or database tables are there, how to create the same representative in the class, that we are going to see over here. So suppose any new constraint is been added in your database, how to add that particular constraint in your entity in Java, that we are going to see over here. So you can match all those particular things. So this is a simple configuration that has been added over here. Now let's move ahead and let's create the entities over here. Let's see how to map a class to the table. So with this particular example that you can see over here, okay, these are the different classes that we are going to create and how to map that. So let's start with the student over here. We'll create the student class and let's see how we can map that particular class to the database. So we have student class which is containing student ID, first name, last name, email ID, and the guardian details as well. So let's go ahead and create that. So I'll go to IntelliJ IDEA in the Java folder. Let me create one package over here. I'll say as entity. Inside this particular entity, let's create the class, and I will call this particular class as student. This is the class. Now to represent this particular class to a database, to make our system know that this is particular entity that you are going to create to map to the database, we have to annotate this class with @entity. And you can see that we are using javax.persistent.entity package over here. Now whatever we do in this particular student class, that will be reflected in our database. Okay. Now what we want in this particular student class, here you can see that we want student ID, first name, last name, email ID, and the guardian details. So let's go ahead and add that. So I'll say private long student ID. Okay. Private string first name, private string last name, private string email ID, and we need to add the guardian details as well, right? So let's add those as well. Private string guardian name, email and mobile number. Okay. Private string guardian email and private string guardian mobile. Okay, so these are the different fields that I have added over here. Now we need to have the getter setters and the constructors and toString method over here. So let's use the Lombok over here. So I'll just define @data using the Lombok. So all the getter setters and toString and hash code and equal methods will be generated over here. And I need all args constructor over here, and I also need no args constructor over here. Okay. One more thing I'm adding over here is @builder to add the builder pattern for my entity class over here. Okay. So this is just a simple thing that I have created over here. Now this student is a particular class that represents the table using this entity. Now table Now whatever the table that we are going to create will always have one primary key to define the unique identifier for all our records. Okay, so how we can create that? So this particular student ID I want to create as a primary key. So I'll define with @id over here of javax.persistent. So this particular annotation @id will define that this particular field is the primary key over here. Now let's run this application and let's see what is happening. Okay, there's a lot of changes that we are going to do, but let's see what is happening till now. Okay, if you go to the database, okay, there is nothing available over here. Okay, I'll go to the main class file over here and I'll just run this application. And here you can see that create table student. Okay, here you can see that whatever we have defined in this particular student class, okay, that particular update operation happened to our database because student table was not available. So, and in our application we have defined the student entity, so that update happened to our database. So this new table is created. And if you go ahead and check in our database, here you can see that this particular tables, we are getting one student table over here. And if you see over here, these are the columns available: student ID, email ID, first name, guardian mobile name, and last name. Okay, here you can see that whatever you defined student over here, okay, in the lowercase, it created the same table name over here. And whatever the camel casing that you have defined over here, and here you can see that using the underscore as a separator, all those particular columns are defined over here. So that's a default format available when you are creating the entities and how those particular entities will be created in the table format. Now this particular table is created, right? Now, as I already told you that when you're working with the production application, you won't be using this particular functionality like DDL auto update. There will be already table created and you need to define that particular table in your entities. Now suppose the name of that particular table is TBL underscore student. How you will define that in your entity? Like this particular student entity is representing that TBL underscore student in my database, because currently if you see that whatever is defined student, the same student table is created. Okay, the column also similar way. So let's see how we can define all those particular things. Now one more thing to note over here is, as I already told you that we are using DDL auto as update. So whatever the update operations we are doing, those particular changes will be happening, and sometimes it may not change the table structure as well. So what we will be doing is, sometimes we will be deleting the table and we will be starting our application so that fresh changes will be applied, so we can see what is actually happening over here. Okay, so let's go back. Let's stop the server and now let's add few of the details. Now what I want to do is, I want to add this particular student entity into my database as a TBL student. I want to represent with underscore TBL underscore student. Okay, so I'll define this using @table annotation. Okay, and inside this table annotation, what is the name of the table? So I'll define as TBL underscore student. Now if I start this particular application, what will happen is, new table will be created with the name TBL underscore student, because whatever changes are already there in the database, it will remain the same and the new updates will be added. This particular Hibernate will understand that, okay, TBL underscore student is a new table that is not present in the database. So let's create it. So it will go ahead and create it. So that's why I was telling that whenever this type of things will happen, we will delete that particular table and we will start our application to apply all our changes freshly. So this is the way that we have defined the name of the table. Now how to define the columns as well. So suppose, let's go ahead and I want this particular email ID as email address, not the email underscore ID. So to define that, we can use @column annotation to define the name of the column. So here I'll define that name of the column is email underscore address. So this defines that whatever the email ID is represented over here, and in the table it will be represented by email underscore address. So this way you can see that we have added the configuration for how our table should be and how our column should be. Ideally, you should define all these particular annotations and all these particular values for each and every field. So here, due to the time constraint, we won't be adding for all the particular fields. Okay, so this is how you can add those particular annotations. Now whenever you're working with the primary keys, you will be incrementing those particular primary keys and you are going to store those particular values. So in the ideal scenarios, you will be using the sequence generator, using the sequence. Okay, so that particular sequence will be auto generated, auto incremented every time when you're going to store the particular data. So let's see how we can add those particular things. So in this particular student ID, we will be adding the sequence generator, how the sequence should be generated, and in the generated values, how we have to use those particular values. So let's see the annotation @sequence generator over here, and here we will define what is the name of this particular sequence generator and what is the name of the sequence as well. So if you're familiar with the databases, you will be having the sequences created and those particular sequence will be incremented when you want to store those particular values. And here I'll define the allocation size as well. Okay, allocation size is 1 and the name of the sequence is student underscore sequence. Define the same over here, that name of the sequence is student underscore sequence. Now we will define how to generate those particular values for the student ID. So we'll use the generated value annotation. Okay, and here we will define what is the strategy. And here we'll define strategy should be generation type dot sequence because we are using the sequence to generate the values. And we'll define the generator, that means our sequence. So this is a simple annotation that we have added. What is the sequence generator, and in the generated value annotation, what particular strategy that you want to use. If you're using auto, if you can use identity as well, but we want a particular thing. We have a particular requirement that we want to use sequence. That's how ideally you should be doing in the production application as well. So we have defined that way, that generation type is sequence, and what sequence that I want to use, that whatever I have defined over here. Now based on the drivers that we have used, this particular sequences will be created. Now if you're using the Oracle, the sequence will be created. In the Postgres also the sequence will be created, but in the MySQL sequences are not there, so it will create one of the tables over here and it will increment the values every time when we are doing the insert operations. Now in our table, sometimes we will be having our different constraints as well. So let's define the different constraints. Suppose if you see my email ID over here, okay, this email ID, whatever I defined, should be unique for every student. Okay, like multiple students cannot have the same email ID. So I want to define a constraint for my table that this particular column should have a unique value. So let's add that particular constraint. So to add that particular constraint, we will go over here in the table annotation, whatever we have defined the name. Here you have unique constraints available. Okay, so let's use this and we will do @unique constraints, and let's define the unique constraints over here. You can add multiple unique constraints over here, so that's why it's a list over here. And here you can see that you can define the name of the unique constraint and the column name as well. I'll define this as email ID underscore unique and column name as email address. Okay, simple over here, right? Now as we are adding this particular email ID as unique, I want that particular email ID from student every time, right? So whenever we are adding the new student in the database, I want that particular email ID, because as we have added the unique constraint over here, that means that particular email ID will define that particular student. So in the columns, we can define the nullable columns and non-nullable columns as well. So this particular email ID should be non-nullable column. That means we should be getting that particular value, right? So let's define that. So in this particular column annotation for the email ID, we will define that this particular nullable should be false. That means every time we should be getting this particular value. If you are not getting this value, it will throw an exception over here. So yeah, you can see that we added a lot of things in our entities over here, right? We define the table information, unique constraint, the sequences, how the sequences should be created, how the value should be incremented, and how a column should be defined. It's a nullable column or a non-nullable column. All those things we have defined. These are the general things that will be available for your tables. Okay, so whatever is there, you can define this way over here. Now I will show you what will happen over here when we run the application. Currently you can see that we already have one student table over here, and when we start our application, as we have defined the DDL auto as update, a new table will be created. Okay, I'll show you that in a second. Here you can see that create table TBL student, whatever we defined over here. Okay, so that means a new table is created. So in our database, there is two tables, student and TBL student. So yeah, what all things happen, you can see that it created the table over here with all these particular fields. Here you can see that it altered the table and added the constraint over here, unique constraint that we have defined. Okay, and you can see that it also created the student sequence table over here, and it added the value 1. So whenever we are adding the values now in the database, that particular one will be used to insert the data, and that particular value will be incremented then. So let's go to the database and let's see what happened. SchoolDB, I'll just refresh it, and here you can see that there are two tables created. Student was already there, TBL student was created. Okay, these are the columns, and if you go to the indexes, there is a primary key that we have defined, and there is also a unique key that we have defined over here. Okay, but I don't want this particular two tables over here. So what you can do is just delete those particular tables and restart your application, so that particular only one table will be created. Now let's understand repositories. So let's go to the application. Let me stop the server. Now as a repositories, there are different types of interfaces available that defines the different implementation of different methods that we can use directly for our entities that we have created. Suppose if you want to save that particular entity, if you want to delete that entity, if you want to get all the records available for all those different standard operations, there are different default implementations added using the different repositories in the Spring Data JPA. So let's check what all the different things are available. So what I'll do is I'll create the student repository and I'll implement the different repositories. I'll show you how to extend the different repositories available for our student entity over here. So let me go ahead and create one package over here, and I'll say as repository. Okay, and for this particular repository, I'll create one interface, and I'll say this is a student repository. Okay, now I'll define this @repository. Over here, it's a stereotype annotation, so Spring will understand that this particular interface that we have created is a repository interface. Now, this particular interface can extend different repositories available. So if you see JPA repository, okay, this is the repository available, and this particular repository, if I open this, now you can see that this particular JPA repository is the interface that extends paging and sorting, repository, and query by example executor over here. And this particular JPA repository is using the generics, which is taking T and ID. T is your entity over here, and ID is the type of the entity that you have defined. So in our case, T is student and ID is of type long that we have defined over here. Okay, now here you can see that there are different methods available, like find all. Like find all will return the list of T available. So T is student, so it will return the list of students available. Find all method is there. This find all is taking sort as the input parameter, so we can define the different sortings over here. It can save all the data, it can flush, it can save and flush. All these particular different methods are available in JPA repository. Now if you see, JPA repository is extending paging and sorting repository. So let's see what different methods available there. You can see find all and find all using the page. So if you want to implement paging to get the different records available using the pagination type, we can do that as well over here. And this particular paging and sorting repository is again extending CRUD repository. So this CRUD repository is having the different methods such as save method, save all, find by ID. So this will defaultly get you the data based on the primary key that you have defined. You can see it's passing the primary key over here. Okay, so it is also have the method like exist by ID if the value record is available or not, find all by ID, count how many records are there, delete by id, delete. So you can see that these are the default implementations available for our repository, so we can directly use this particular methods to reduce our efforts over here. And there are a lot of different functionalities extra available that you can use to create the different implementation, custom implementation as well. So we are going to see all those particular things in the later part of the video. So you can see these are the methods available. Let's close these things. Okay, let's define the JP repository for now over here, and we'll define that it's of type student and of type long over here. Simple thing. Now let's test whatever we have created over here. Okay, so ideally you will be creating the REST APIs and you will be calling those particular repository methods from the REST API. Here what we'll be doing is we won't be creating the REST APIs, we'll be just creating the test class to test this particular repository that we have created to save the time over here. Okay, and if you want to understand how to create the REST APIs and how to interact using this particular repositories, I have created a dedicated video, Spring Boot tutorial, the advanced course. You can go ahead and check that out as well. In this particular video, our main focus is to how JPA works. So we'll be only focusing on the repository layers. Okay, what we'll be doing is we'll be creating the test class for this, and we will create the different test methods, and we will call the different methods available for the student repository and call them. With alt insert, you can go for the generate and you can generate the test class. So I've just defined the simple test class over here, that is student repository test over here, and I will annotate with Spring Boot test over here. Now ideally you should not be testing your repository layer using the Spring Boot test. There is a different annotation available, that is @data test. What this particular thing will do is it will help you to test your repository layer, and once the operation is completed it will flush the data, so the database won't be impacted. But currently we want to impact our database. We want to store our values into our database so we can see what's happening over here. So that's why I'm going with the standard testing over here. Now for this student repository test, we need a student repository. So let's go ahead and create the object for it. Student repository, and I will auto wire it. Okay. Now let's create one method to save the student over here. So what we will do is we'll create the method public void save student. Okay, and I'll annotate this particular method with test, so we can run this particular test case. So don't focus on the test cases that we are creating, just focus on what's happening when we are using the repository, how Spring Data JPA works, and how we are going to store the data, how we are going to fetch the data. All those particular things are more important in this particular course. Okay, so to save the student, we need to create the student object with all the values that we have. In the student class, you can see that we have used the builder pattern, so we are going to use this builder pattern to create our object. So what we'll do, I'll just say student equals to student dot builder dot, we are not going to store the student ID because student ID will be auto generated using the sequence that we have provided. Let's pass the email ID. I'll say shabir@gmail.com. I'll say first name as Shabir dot last name as Daudi, and let's add my guardian name as well. I'll just say any name, Nikhil. Guardian email as nikhil@gmail.com. Guardian mobile 2 3 4 5 6 7 8 9 10. Anything remaining, guardian email, guardian name, last name, first name, email ID, guardian mobile. Okay, and build. So this particular object is built. Now what I want to do is I want to do student repository dot save. What I want to save, this student object. Simple. Okay, so I'm just using the save method of a JP repository. JP repository is again extending the CRUD repository, so you can see that this particular save method is part of the CRUD repository over here. Currently if you go and check the database, this particular student repository is going to use the tbl_student over here. Currently you can see there is no records available. So let's go ahead and run this particular method. Okay, you can see that this particular method is successful. Now if you go down over here, you can see that these are the particular different queries that are being executed. You can see that select next val as id val from the student sequence. Okay, so it took the value from the student sequence that we have created, and after that it updated the sequence to the new value. Okay, and it inserted the data into TBL student over here. Okay, so these are the three queries that has been executed over here, and if you go ahead and check the values over here, you can see that we got the values. Student ID as 1, email ID, first name, guardian email, guardian mobile, guardian name and last name. All the particular data has been saved over here. It's cool, right? With one method, with one line of code, you are able to save the data over here. Now let's create one more method to get the list of students available in the database. So let me just create one more method, public void print all student. Okay, and this is also I'm going to annotate with test over here. And what I'll do is I'll just define list of student list, and this is from java.util equals to student repository dot find all. Simple over here. Okay, and let me just print it. Okay, let's run this particular method as well. Now as we have only one student available, that particular student will be printed over here. Yeah, you can see that the query was executed. Select all the particular columns from that particular TBL underscore student over here. Okay, and this is the data. Student list equals to first student, that is student ID, first name, last name and all those particular details available. Cool. So everything is working fine. Now in this particular student class that we have created, there is an improvement that we can do. So let's see what we can do over here. Now if you see over here, this particular student class contains this particular fields over here, that is guardian name, guardian email and guardian mobile. Ideally this all details should be in this separate class, because student is a separate class, is a separate object, and guardian should be a separate object, and there has to be relationship between these two. There has to be different relationship available, but ideally this particular data should be saved in a single table in my database. Okay, so let's see how we can do that. So this particular property is available, guardian name, guardian email, guardian mobile should be in the different class itself. So let's go ahead and create the guardian class. Okay, and this particular guardian class will be having those properties. I'm just removing from here and I'm adding those properties over here. But this particular guardian class cannot be an entity, because I don't want to have the different table for it. I want to use this particular properties for my student table only. So how we can do that? We can do using the embed. Okay, we can embed this particular class inside my student. So for my student class to embed this guardian class, this particular guardian class should be embeddable. So I'll define this as embeddable. Simple, right? So this particular class is embeddable. Now I can use this particular class in my student. So let's go back to student, and here I can define private guardian, and this is embedded. Now this particular guardian class should also be annotated with @data, because we need data setters, we need all args constructor, we need no args constructor as well. Simple over here, right? Now as all these particular properties are inside this particular guardian class, can be directly named, right? Email and mobile number, which makes more sense. Okay, but now what happens once we do this? Because as we have the properties in our table, that is guardian email, guardian mobile, guardian name, and here we have defined as name, email and mobile over here, we need to map it together. Okay, so here what we have to do is we have to map this particular attribute to our database that we have. all these particular properties. So we need to use the attribute overrides annotation over here. So let's see how we can do this. So what I want to do, whatever the properties are there, this name, email and mobile number should represent to Guardian email, Guardian mobile and Guardian name over here. So let's see how we can do. We can use attribute overrides annotation over here, as we want to override multiple attributes. I'll define the list over here, and here I'll define attribute override over here, and it have name of the attribute and the column name. So let's define those things, and column over here. So the name of the attribute is this one, this name, and here we need to define the column over here. Okay, and in this particular column, this is a column, so we need to define column over here, and this has the name of the column we need to define as Guardian underscore name, whatever is over here, Guardian underscore name. Okay, cool. Now the same thing we have to define for the rest as well, email and mobile. So let's go ahead and do that. We'll say attribute override, and I will say name equals to whatever the name is email, and column equals to column, and name of the column is Guardian underscore email. Okay, one more attribute override. The name of the attribute is mobile. Okay, and column we have to define column equals to column, and inside this let's define the name equals to Guardian underscore mobile. Hope the spellings are correct. Name, mobile and email. So we just define the 3 attribute overrides, like this particular attribute should define to this particular column name, and this particular Guardian we have added as a property in our student. So all good. Now there will be a issue how we define how we create the student object. So if you go to the student repository test over here, you can see that now there is no longer a Guardian name available. Let me just comment it over here for now. So there is no issue for now, and let's create a new method, save student with Guardian. Okay, public void save student with Guardian details. I'll annotate with test over here, and let's define student equals to student dot builder dot build. Okay, so here I need to define dot first name as Shivam dot email ID as shivam@gmail.com, last name as Kumar dot Guardian. Now this Guardian will take the entire Guardian object. Okay, so let's build that as well. So what I'll do, I'll just create the Guardian object over here. Guardian equals to Guardian dot. Okay, let me go to the Guardian and let me define the builder pattern over here. Now you don't have to do this. Okay, I like builder pattern and I like the way it looks, so that's why I'm doing it. Okay, Guardian builder dot build email. I'll use the same information. Okay, Nikhil is the Guardian. Dot name as Nikhil dot mobile as 1 2 3 4 5 6 7 8 9. Okay, some number and build over here, and I'll use this Guardian over here, and I need to save this object. So I'll just say student repository dot save student. Now let's run this. Yeah, you can see that it is successful, and Here you can see that the select for the sequence, update for the sequence, and insert into table over here. And if I run the query again, you can see that we are getting the record Shivam and all these particular details. So here you can see that we separated out the two different classes over here. Okay, that is guardian and student, but we represented the same in our database over here using the embeddable and embedded over here. So if you have something like this when you are using the inheritance parent-child relationship, you can go ahead with this particular approach. Now let's see the different methods available, how we can create the different methods in our student repository. So suppose we saw that there are only few of the methods available in our student repository, but if you want to create the custom method, suppose I want to get the student's record based on the name of the student. So let's see how we can do that. So in the student repository, student interface, we can define the methods. So I'll just define public, and I'll say my return type is list of student. Okay, and the name of the method that you give over here, it has to be in the format that has been defined. So I can define find, and by what? By by capital, and then you need to define the attribute name. So if you go to the student class over here, and here you can see that it is first name over here. Okay, it is in the camel casing. Here also it should be in the camel casing. So I'll just define over here, and as it's in camel casing, F should be capital over here. Okay, find by first name, and then you need to pass the string over here that will be containing your first name. So I'll just say first name over here. That's it. You just need to give the definition. You don't have to implement it. So I just define one method that is find by first name. So let's go ahead and test it out. We'll go to the student repository test over here, and let's create one more method. We'll say public void print student by first name. I'll annotate together test. And I'll say I just need list of students equals to student repository dot find by first name that we have defined, and I want the records that is having first name as Shivam over here, and let's print it. Let's run this. So we should be only getting Shivam over here, and we'll see what query we are getting out of it. Okay, so here if you scroll down over here, you can see that we got the one record which is having first name as Shivam over here. Okay, only one record over here. Now if you see the query, here you can see that it is doing select from all the particular columns available, and at the last, if you go where student.firstname equals to whatever the value that you are passing over here. So this way you can see that you can create the methods. Now suppose you want to create the methods to fetch the student who's containing first name as some of the characters. Okay, so suppose currently you see that we have just defined that first name is exactly matching that you provide over here. But suppose if you want to get the particular students with some of the particular characters that you want to match, so that you can define using this way. I'll just say I just need list of student find by first name, and I'll say containing, and I'll pass string name. Okay, simple. So what I defined over here is I need the records based on the first name, but it has containing characters. Okay, I don't want to match the entire string particularly, but if we have some of the characters, I want that particular records. So let's go to the student repository test again. Let's copy paste this method, first name, I'll just say containing, and here also I'll just say find by first name containing, and I just need data which contains sh. So let's run this. So here you can see that the query executed. If you go at the last, okay, you can see that the first name like whatever you have defined. Okay, like it's doing the escape characters. Okay, percentage, whatever the name that you are giving, and percentage over here. And here you can see that you got both the records, Shivam and Shabir, both the one. So this way you can create the different methods as well. Let's define one more method. Okay, we'll just say I just need a list of students. Okay, find by, suppose, last name. We just implemented the method to get the data by first name. Now find by last name, and that should be not null. Okay, simple. I want the records which are not null. Okay, so it will check that last name is not null. We will get those particular records. Now suppose you want to get the data based on the guardian name, so that also we can do. We can just say list of student find by. Now this you need to define based on the attributes. So in the student table there is an attribute called guardian. Okay, so you need to define that, find by guardian. This G should be capital, right? And for which particular attribute in that guardian as well. In the guardian I need the data based on the name, so I'll just define name. Simple, right? And I'll just say string guardian name over here. Let's test it out, this method as well. Let's go to the test class and let's implement a method public void print student based on guardian name. I'll annotate with @test. Okay, and let's implement this. I just need list of students equals to student repository dot find by guardian name, and guardian name I'll define as Nikhil, and I'll print this out. Let's run this. You can see that how simple is this, right, to implement all these particular different methods. Here you can see that the query is select all the records, and at the last you can see that where student dot guardian name equals to this. Okay, so with this particular name that we are defining over here, JPA is able to understand what we are saying over here. Okay, and we got both the records, that is Shabir and Shivam, as both is having the same guardian over here. Now if you go to this particular documentation, if you go to the Spring Data JPA, learn, and go to the reference documentation over here and go to the query methods, and here you can see that there is a list available over here. Okay, how you can define your method name. Currently you saw that we defined few of the methods over here in the student repository. Okay, find by first name, find by first name containing, find by last name not null, find by guardian name. And here you can see that the list available how you can define your own method name as well. So if you want to get the distinct records, you can say find distinct by first name, last name, or whatever you want to give over here. And if you want to get the records based on the two values, suppose you want to get the data based on your first name and last name, so here you can see that and keyword you can use, like find by last name and first name. So you can define this way, like find by first name and last name, I want to get the records, and in the parameter you can define that way. Suppose I want student, okay, find by first name and last name. Okay, and here I need to define two values over here, string first name and string last name over here. This by should be small over here. Okay, find by first name and last name. And here you can see that if you want to get the records by find by first name or last name, you can define that way as well if you want to match the particular values. And here you can see that how the sample should be, and here you can see that how the JPQL snippet is for that. So how a JPQL query will be represented
for that particular thing. We will come to that part, how to add the JPQL queries, how to get the data based on the JPQL queries as well. But if you come over here, you can see all the different examples over here, and based on this example you can create your different method names. Okay, here you can see that if you are using any values like find by start date between, find by age less than, all these things you can do over here. You can see that we use this particular one, right? Find by not null, we define find by last name not null. You can use the like operator, not like operator. Okay, starting with this, ending with this. We use this one containing, right? Containing any of the particular characters over here. You can use order by, last name not, last name in, not in this. It's true false. If you have a boolean values, you can go with the find by true, find by false as well, and you can go with the ignore case as well. So you can see that if you define ignore case, both the places when you're matching, the values will be used as a uppercase. So this way you can go through this particular article. I will add the link in the description below so you can check that out. These are all the different ways that you can create the method as well. Now the time comes when creating the method name is not enough. You have to create the different method name, and you have to specify the different query as well, right? Like based on this query, I want to get the data. So for those particular cases, you can use the @query annotation, and you can pass the JPQL queries as well. So let's see how we can do that. Let me go to the IntelliJ IDEA and let's create one method over here. What I need, I want student, and I'll just define get student by email address. Okay, now this is and I'll define string email ID as well. Okay, I want this particular method. So here you can see that I've just given the different name over here, so you're not confused like with this particular default implementation methods over here. I just gave the get student by email address over here. Now here what I want is, as our email ID is uniquely identified, as we have added the unique identifier for this email ID, I want that particular student based on the email ID that I have provided. But I want that data based on the query. So I need to pass the query. I can give that query using the query annotation. And here I can pass the JPQL queries. Okay, if you go to this particular document, you can see that these are the JPQL queries snippets over here. Okay, select distinct and all those things. And if you come over here, what I can do, select, I can define select as from student s. So the JPQL queries are defined in a separate way rather than the native SQL queries, but this is a very simple over here. Okay, so the JPQL queries are defined based on the classes that you have defined, not based on the table names and the table attributes, table column names. This will be defined based on your class that you created and the attributes that you are using in your class. So you can see that I'm not going with the tbl_student. I'm going with the select as from the student class that I have created, and I want the student where s dot whatever the attribute name. In here you can see that my attribute name is email ID. Okay, so I'll define s dot email ID equals to $1. That is the first parameter. So I'll just define here as this is the JPQL as well. So here you can see that we just defined a simple query over here, that is a JPQL query. JPQL queries are based on the classes that you have created, not based on the tables in the database. Okay, so that's the one thing that you have to take it in the mind. So student is the class that we have created, email ID is the attribute property in my student class, not the email_address that has been defined over here. Okay, here is email_address, but we are using this particular thing over here, and this should be small email, right? Now let's create a test method to get the data. I'll use this name only, public void print get student by email address. Okay, and I'll annotate with @test over here. What I'll do, student equals to student repository dot get student by email address, and here I'll define the email address. I just say shabbir@gmail.com. okay, and I'll print this student over here. Simple thing that I've defined over here. Okay, nothing complex. So let's run this. Yeah, you can see that the query is executed. Select student, all the particular values, and at the end you can see that email address equals to whatever the email address was passed. And here you can see that only one record has been fetched over here. Now suppose if you want to have only one value, suppose let me copy this thing, okay, and I'll just say get student, I'll just say first name. Okay, so I just need the first name by the email address that I'm providing over here. So here I'll define s dot first name, that I just need first name. I'll go to the student, I'll just copy this from here, and I just need s dot first name from the student as where s dot email id equals to parameter 1, that is email id that I'm providing over here. And I don't want as a student, this is the string over here, because I'm just getting the one value over here. So let's go ahead and test this as well. Public void print this, I annotate with other test. This is string, right? So I can directly use string first name equals to student repository dot get student first name by email address, and I'll just define this email address, that is shivam@gmail.com. okay, and I'll just print this. Very simple thing over here. Let me run this, and here you can see that the query was executed. Select only first name as the first column from this particular table where email id was whatever was provided over here, and only one particular value was printed. Okay, so you can mix and match this way, and whatever the way you want to define the particular queries and the way you want to get the data back, you can define in the particular method this way. Now you can see that we have defined a lot of methods over here, right, in this particular repository. Now let's take to the another level. Now you have a very complex objects and you have a very complex query that you are not able to define from the JPQL as well. So Spring Data JP also gives a support for the native queries as well. So you have a native SQL query that you can define using the @query, and you can define that this is a native query and you want the data based on that. So that also we can define. So let's go ahead and see how we can define that. Let's create one more method. Let's take the same example. Okay, let's take the same get student by email address example, but instead of JPQL query, I'll pass the native SQL query. So I just need student from here, this particular method, but I'll just define this is a native one. Okay, and I'll pass a string email id over here, and @query I'll define, okay, and the value of the query, what is the query that I'll be defining over here, and then I'll define that this is the native query. Cool, right? Let me define the query now. So the query should be select star from tbl underscore student. Okay, if you go to the database, let's copy paste this query, okay, directly. I don't want this one, schema name. I'll define s where s email underscore address equals to $1. Here you can see that with the @query notation, we provided the value over here, and that value is select star from tbl student where s.email address equals to $1. That is the first parameter, and we have also defined that this particular @query, whatever the value that we are passing, that is a native query. So that is a native SQL query. Now let's go ahead and test it out. So let me just copy paste this. I'll go to the test and create one more method. Public void print this. I'll annotate with other test over here, and I'll say student equals to student repository dot get student by email address native. Okay, and I'll pass the email ID over here. Let's print this and let's run this. And here you can see that we are getting the data over here and the query is executed, whatever the query that we have defined over here. Okay, so the new query is not generated based on the method name that we are giving or based on the JPQL query that we are passing over here. This is the same query that we have defined and the same query is directly executed based on the native query equals to true flag we have defined, and we are getting the data as well. So whenever you have a very complex queries to work with, you can go ahead with this particular implementation to work with the complex queries as well. Pretty neat, right? Okay, so I'll just define this is a native query. Now suppose if you have a multiple parameters that you're passing over here, passing with question mark 1, question mark 2 is not always the better approach. So what you can do is you can go with the named parameter values. Okay, so you'll be defining a particular naming parameter, that particular name parameter that you will be defining in your input parameters as well. So let's go ahead and see how we can do that as well. So let me go ahead and create the same thing over here. Okay, I'll just copy paste the same thing. Instead of native, I'll define native named param. So I'm defining the named parameter over here, and instead of question mark 1 over here, I'll define colon email ID. So this is much more readable, right? And here I need to define that @ parameter. Parameter is email ID. So here you can see that I'll just define native name param. So it's more understandable for you when I'm sharing the code with you. Okay, so this particular query that I have defined over here, that query equals to whatever the query I have defined, and I have passed the named parameter values, and this is the particular method I have defined, and inside this particular input parameter I have defined that this particular input parameter defines the colon email ID parameter over here. And if you have multiple, you can add the multiple values over here and you can pass @ param for all those particular multiple values that you have. Now let's go ahead and run this as well. Okay, I know this will be a little bit boring for you guys, but I'm trying my best to make it more understandable for you. Okay, so let me copy paste all these details. Okay, and the method is native named query named param. Okay, so yeah, you can see that this is the named parameter method that I'm calling. Let's run this out, and you can see that we are getting the record. This is the same way. Cool, right? Now the next one is really awesome. Currently you see that whatever the methods that we have defined over here, all those particular methods are to fetch the data. All these particular, as you can see, all the native queries, all the JPQL queries, everything that we have defined are all fetching the data. What if you want to update the data or delete the data? Okay, that also should be possible. So that is possible using the modifying annotation. So let's see that as well. So let me go to the student repository. Okay, and currently you saw that whatever the queries and everything that we have defined, everything is fetching data. Now let's create one of the method that will update the records. Now the method that I'm defining over here is to update the first name of a student based on the email ID that we have. So I'll just define integer update student name by email ID. Okay, this is the name of the method, and here I'll be passing string first name that I want to update and string email ID, for which particular email ID I want to update the first name. Now as always, we can define using the query annotation. This will have the value what is the query, and I'll also define this is the native query as well. So the query would be update table name, that is tbl_student, set first underscore name equals to question mark 1, where email underscore address equals to question mark 2. So this is a simple update query that I have defined over here. Now to make this method to modify the values in our database, we need to annotate with @modifying. Now as this is a modifying query, as it is modifying the data, there has to be a transaction for it. Okay, so all the particular methods that we want to make it transactionable, so a transaction is created, some of the operation is been performed on it, and that particular transaction is been committed back to the database. That all the things we can do using @transactional annotation. With one simple annotation, a transaction will be created. All the operations like insert, update, delete, whatever that we want to do, we can do all those things. And at the end, after that particular operation is been performed, when that particular method has been completed, that particular transaction will be committed to the database. Ideally, all this particular transaction will be adding at the service layer when we create a service layer, and we can call the multiple repository layers from that service level to make it entire flow as a transactional. Suppose if you want to insert 3 records inside a 3 different table, you will annotate your service layers method with @transactional. You will call the 3 methods of the repository layer, and once everything is completed successfully, then only at the end your transaction will be committed. Otherwise your transaction will be rolled back if there is any error in it. So that's how ideally a transaction will be implemented. But for now we are adding in the repository layer because we are more focused on the JPA for now. This is the transactional annotation that we are using over here that you can use at your service layer wherever you want to create a transaction. You can create a transaction as a method level and a class level as well. Now let's go ahead and test this particular thing. Okay, so what we'll be doing over here is we will be giving the first name and email ID over here to update the record. So let's go to the test class over here. Let's create one test. I'll copy paste this particular thing, public void I'll annotate this particular method with other test over here, and I need to call student repository dot update student name by email ID. And we need to pass first name and email ID. Suppose I want to update this particular record, that is shabbir@gmail.com. So I'll just pass this information that for this email ID I want to update the record, and my first name should be, suppose I'll just say Shabbir Dawoodi. Okay, just for the sake of simplicity I'm just adding this detail over here. Okay, now let's run this, and here you can see that update query was executed. Update this table, set first name equals to whatever the value, where email address equals to this particular email address that we have passed over here. And if we execute the query again, here you can see that my first name has been updated with the new values that we have defined over here. So we just saw that we have defined 2 annotations, that is @transactional to define a particular transaction for this particular method, and also @modifying annotation whenever you want to execute any queries that has been modifying the record in your database. The same will be applicable when you want to delete the records as well. So here you can see that we saw a lot of things about the repository, different repository methods, how to create a different methods, how to use the queries, how to use the native queries, and how to modify the queries, how to modify the records using the modifying annotations as well. Now we will see the different relationships available in the JPA. Now firstly we will check one-to-one relationship in JPA. Now with this particular class diagram you can see that we have 2 classes, that is a course class and a course material. And for this particular 2 classes, that is course and course material, there is a one-to-one relationship, because for one course there will be a one course material, and for a course material will be only available for a particular course over here. So this is a one-to-one relationship. And for this particular thing, how a table will be created is like, you can see that for a course that contains a course ID, a course title, and a course credit, and other course material is having a course material ID and the URL to it. So what will happen is either of the table will contain a foreign key of the other particular table that we have. So a course ID is a primary key for the course table. So that particular course ID will be behaving as a foreign key for a course material table over here. So let's create these two classes, course and course material over here, and let's see how we can define one-to-one relationship. So let me go to the IntelliJ IDEA, and with this particular entity package, let's create course entity and a course material entity over here. So I'll just create a new class that says course over here, and I'll create one more entity that says course material over here. Okay, let's go to the course and let's define this as an entity, and we'll annotate with @data for Lombok, @allargs constructor, @noargs constructor, and @builder. Just the standard stuffs. Okay, let's do the same for the course material as well. @entity, @data, @allargs constructor, @noargs constructor, @builder pattern. Now let's create the attributes over here. So here I'll define private long course ID, private string course title, private integer credit over here. So these things are defined over here. Now let's define the course material ID and URL in our course material class. So let's go to the course material. I'll say private long course material ID, private string URL for the course. Okay, just a simple thing over here. Now this course material ID and the course ID in the course class both have the primary key, so we need to define the primary key for it, and we need to define the sequence generator and the generated values, how the values are generated. So let's do that. I'll annotate with @ID over here, and for this course ID let's define sequence generator, and the name of the sequence generator I'll define, sequence name we will define, and the allocation size I'll define over here. So I'll just say course sequence, and the sequence name is course sequence. Okay, and how the values are generated. So @generated value, strategy would be generation type dot sequence, and the generator would be course sequence over here. Let's define the same thing in course material. @ID, @sequence generator. Well, I'll define the name of the sequence generator and the name of the sequence as well, and I'll also define the allocation size, that is 1, and I define course material sequence. Okay, and generated value, I'll define the strategy equals to generation type dot sequence, and generator equals to course material sequence over here. Now we need to define the mapping over here. Now between course and course material, the mapping that we can define is course material will consist of a course. Okay, course material cannot exist itself, it has to have a course so that we can add the course material to it. So for that, in the course material we'll define private course over here. Okay, and for this particular thing we will define 1-to-1 mapping. Now this we have defined that this is a 1-to-1 mapping. Now we need to define for which particular column that a foreign key will be applied. Okay, so for that we need to define join column over here, for which particular column that we can join these two particular tables. So here I can define name of the column, and I can define the reference column name. So which particular column it is referencing to. So inside this course, it is referencing to course ID over here. and what's the name of the column? That would be course ID. Okay, simple. We just define what will be the join column. In the referenced column name, we define which particular column this is referencing to. So in this course, it is referencing to this course ID, this particular attribute. And what would be the name of that column? We have defined that the name of the column should be course ID. So in this particular course material table that we are going to create, this particular course material table will have an extra column that will be course underscore ID. So that will refer which particular course this belongs to. Now all the standard stuff that we saw earlier, all the things applied here as well. That we can define @column, we can define @table, we can define the unique keys, we can define different constraints over here. Everything we can do over here also. But we have a limited time, so I'm considering that you can do all those things by yourself by referencing to what we did in the student class. Everything you can do here as well. So let's go ahead and let's start our application and let's see what are the different tables is created. So I will just run the application, and once the application is successfully started, you can see that there are the different queries created. You can see that table course is created, okay, course material sequence is created, course material sequence value has been inserted, course material table is created, and the course table has been altered, adding the foreign key over here. And if you go to the database over here, and if you refresh the database, here you can see that course table has been created, course material table has been created, and the two sequence tables are created. And if you open the tables over here, let me open the course table, and here you can see that in the course there are 3 columns over here. That is course ID, the name of the title of the course, and the credit available. And if you go to the course material, you can see that course material ID, the URL of the course material, and the course ID which this particular course material belongs to. So this way we have added the primary key and foreign key relationship between the two tables. So here for every course there will be one course material. That is a one-to-one relationship. Now let's create the repositories for our course and course material over here. Okay, so let me go to the repository and let's create the interface over here, and I'll say this is course repository. Okay, and this extends JPA repository, and this is of course, and long is the ID over here, and I'll annotate with @repository. And I'll create one more, that is course material repository, and I'll extends JPA repository with the course material and long, and this is @repository. Okay, we just created 2 repositories, course repository and course material repository. Now what we will do is we will test this particular thing out. So we'll create a test class for this course material repository over here, and we will try to save a course material with the one course over here. Okay, so let's generate the test class over here. This is a particular test class that we generated. Let's annotate with Spring Boot test over here. And for this particular course material repository, what we need is private course material repository, and I will auto wire it. So this is the particular repository's object that we want to create the different methods. So let's create one method to save the course material with the course. So I'll just say public void save course material. Okay, and I'll annotate this with @test over here. Now let's create the course material equals to course material dot builder dot URL. So what's the URL? I'll just say www.google.com.course, and here we need to pass the course object over here dot build. So let's define the course object as well. Course equals to course dot builder dot course title equals to, let's say data structures and algorithm dot credit. I'll say there's a 6 credit for this particular course dot build, and I will pass this course to my course over here. Now let's save this course material. So I'll just say repository dot save course over here. Sorry, course material over here. Okay, simple thing, right? We created the object of a course material over here, and this course material has to have a course for which particular course that we want to save the data. So we defined that as well over here, and we are trying to save that particular course material over here. So now let's run this and let's see what is happening over here. Okay, so let me run this, blah blah blah, and it failed. Okay, let's see why it failed over here. And here you can see that the error is invalid data access API usage exception, transient property value exception. Okay, object references and unsaved transient instance. Okay, object references and unsaved transient instance over here. For what? Course over here. Okay, what we are doing over here is we are trying to save the course material without saving the course over here, because what is happening over here is we are trying to save the course material, and for this particular course material we have to have a course that is already saved in the database, but it's not. We have not created any of the course over here. What we are trying to do is when we save the course material and we also pass the course, and if that course is not available, we need to create that course as well. To make this thing happen, currently you can see that it's not happening, but to make this thing happen, cascading comes into picture. Once we implement the cascading means what? Cascading means to pass the properties or to pass the permissions to your child elements from the parent to child. Currently you can see that I want to save the course material and I want to persist it, and we have a course that is not persisted, so we will cascade the information. We have different cascading types, so we are passing that information. Okay, I'm trying to persist this particular course object is not available. Okay, no problem, try to persist that as well. So there are different cascading types available. Okay, that's an enum available, so we can define that, and accordingly what we define, this particular operation will happen. So let's go and define that. So we'll go to the course material, and in one-to-one mapping over here we'll define cascade equals to cascade type dot. You can see that there are different options available, that is cascade type dot all, detach, merge, persist, refresh, remove, whatever. So whatever you define, the operation will happen accordingly. For the simplicity, I'll define cascade type dot all, so whatever the operations are there, everything will happen over here. Currently you see that in the course and course material there is no data, there is no course material, and there is no course as well. If you go back to our IntelliJ IDEA, if you go to the test class, earlier it failed. Now let's run it again. And now here you can see that this is successful, and if you go down you can see that how many queries happened. You can see that first the course was inserted. Okay, after that course material was inserted over here, and if you go to the database and if we run the query, you can see that the course is created with course ID 1, credit 6, title is DSA, and if you come to the course material, this course ID should be used over here. You can see that course ID 1, the URL is this, and the course material ID is 2. So with this particular cascading type information, we were able to do this. Now once we go back to the course material over here, okay, there is a different thing available that is called fetch type. How you want to fetch the data. There are two types of option available, that is eager fetching and lazy fetching. So what's the difference between that? The difference is, so if you are having a relationship between the two tables, so once you call the data of a parent, so suppose currently when you call the data of a course material, do you need to fetch the course also with that, or you just need the course material only? So based on the application that you have, you can define the fetch type. So when you define the fetch type as eager, it will bring the course data as well when you try to bring the course material. But when you define fetch type as lazy, it will not bring the data of a course until and unless you specifically ask to bring the course. Okay, so in this particular one-to-one relationship, there is a fetch option available. So with this particular fetch, you can define either is a fetch type eager or fetch type lazy. So I'll just define fetch type lazy over here. Now let's go back to the test and let's add the method to print the course materials. So I'll just say public void print all courses. I'll annotate with the test over here, and I'll say list of courses. Sorry, I'll say list of course materials. Okay. Course materials. And I'll say course materials over here. Equals to repository dot find all. Okay, and I'll just print it. Okay, simple method. So let's run this. Okay, you can see that it is throwing the error that could not initialize the proxy for the course. So what I'll do over here is there's a toString method that is calling the course over here. So I will remove it for now. So I'll just define @toString and I'll exclude course over here. Let's run this again. Now as we have defined the fetch type as lazy, you can see that we are getting only course material over here. We have excluded the course as well from the toString method, so it won't call that particular get course method over here. So ideally, as per the requirement that you have, you can define that what should be your fetch type. Either it would be eager or lazy over here. Now you can see that we defined the find all method for the course material over here. Now let's go to the course and let's get the courses available over here. So let me go to the course repository over here and let's create the test class for this as well. I'll add the Spring Boot test over here, and I need to add the course repository as well. So I'll just add private course repository and I'll auto wire it, and I'll have a method public void print courses, and I'll annotate with either a test over here. I'll have list of courses equals to course repository dot find all. Okay, and I'm printing the courses available. So let's run this. Now here you can see that you are getting the list of courses available. Okay, what is the course available? Now ideally when you're getting the courses, you want the course material as well. So ideally when you are getting the courses, you want the course material as well, because then only you'll be identify what's the material for that particular course, right? There is no point of getting two details separately. But how to get the course material from this particular course repository? Because you have created the course material repository, okay, and when you are working with the course material object, you are getting the course material with the courses as well. But when you are working with the courses, you are not getting the course material. Why? Because you have defined only unidirectional one-to-one mapping over here. We don't have any course material references in our course. So you can see that in the course material you have a reference to courses, but if you go to the courses, you don't have any reference to course material, because you have only defined unidirectional one-to-one mapping. Now let's see how we can define the bidirectional one-to-one mapping over here. So for this particular courses, you need the reference to the course material, but you already defined one-to-one mapping over here. So what we can do is we can come to our courses entity over here, and here we can define private course material over here, and here you can define this is one-to-one mapping over here. But here you cannot define the joining columns, right? Because you already defined in the course material. So here you need to say this is mapped by some other class, right? So you can tell this is mapped by what? This is mapped by this particular course in this course material class over here. So what you are defining over here is you need a reference of course material in your courses to define one-to-one bidirectional mapping. But that one-to-one mapping to join a column for a foreign key is already defined in the course material. So you're telling that this particular one-to-one mapping is already defined by the courses attribute in course material class over here. So in this course material class, there is a courses attribute that has already defined one-to-one mapping over here. Cool, right? Now let's test it again. Now if you go back to the test over here, and already earlier you can see that we only got the course over here. Now if we run it again, we should get the course with course material. So here you can see that the test case is passed over here, and if we go down over here, you can see that we got the course, also we got the course material as well, right? So we defined bidirectional one-to-one mapping. So we define the reference of course material in the courses as well. So this is how you define unidirectional or bidirectional relationships in any of the relationship types. Either it is one-to-one, one-to-many, many-to-one, or many-to-many relationship. So I just showed you in one-to-one, the same concept and the same implementation goes in all the other three as well. Now let's see one-to-many relationship. Now if you come to this particular architecture that we have defined over here, we just saw course and course material that is having one-to-one relationship. Now if you come over here, teacher and courses over here, that is having one-to-many relationship. One teacher can teach multiple courses over here. So that is a one-to-many relationships. And the reverse would be many courses can be taught by one teacher. So that would be many-to-one relationship. So let's go ahead and first see one-to-many relationship, and then we will see many-to-one relationship. So let me go back to the IntelliJ IDEA. We already have course and course material classes created. Let's go ahead and create the teacher class as well. So teacher has teacher ID, first name, last name. So let's go ahead and create that. So I'll go to the entity and let's create the Java class says teacher, and I'll annotate with @entity over here, @data over here, with all args constructor, with no args constructor, and build a pattern. Now this teacher has private long teacher ID, private string, first name, private string, last name over here. These are the three fields available for a particular teacher class. You can add multiple, but let's add it only three for the simplicity over here. This particular teacher ID would be our primary key. Okay, and we need to define the sequence generator and generated value as well for here. So I'll just define sequence generator. The name of the sequence generator I need to define, the name of the sequence I need to define, and also allocation size I'll define as 1. I'll just say teacher underscore sequence over here. The same value I'll define over here in the sequence name. Okay, the spelling is wrong. I'll just correct it out. Okay, and I'll define the generated value as well. @generated value. I'll define the strategy equals to generation type dot sequence, and generator I'll define as teacher sequence over here. This is a simple thing that we have defined over here. Now what we can do is this particular teacher and course have a one-to-many relationship. One teacher can teach multiple courses. So a one teacher can have a list of courses inside a particular class. So I can define this way, right? If I go to this particular teacher class, I can define one attribute as private list of courses. Okay, that this particular teacher have a list of courses which a particular teacher can teach. So I can define this particular is a one-to-many relationship. As we defined the cascade type in the course and course material, here also we'll define the cascade type. I'll just simply say cascade type.all for now, simplicity. Now for this one-to-many relationship, there will be two tables. One will be teacher, one will be course. For every teacher, which particular course that particular teacher is teaching, that particular relationship will be having. So you can consider that course table will be having a extra key, foreign key, that is a teacher ID. That particular column will define this course is taught by which particular teacher. So we need to define joining column over here. So we can define joining column, name of the joining column, and reference column name. So what will be the reference column? Reference column will be this particular teacher ID. Okay, and what would be the name of the column? I can say teacher underscore ID, whatever you want to name the column. So this is a simple unidirectional one-to-many mapping over here. Okay, and we have defined cascade type as all over here. I hope this is very clear. This is a very simple thing. We just define one-to-many relationship between two particular classes, that is teacher and course. Teacher can have a list of course that a particular teacher can teach. Okay, so we just define that way over here. Now let's start the application. Okay, and a particular teacher table will be created. Yeah, you can see that my application has started, and you can see that teacher table was created. Okay, and the course table was altered, and a new foreign key was added to that particular course table over here. Simple, right? And if I go back to this particular database, and if I refresh my database, you can see that now course table was having only 3. Now if I run it again, you can see that new teacher ID has been added over here. And if you see over here, there will be new teacher table also created. What's the teacher available? Now let's go ahead and create the teacher repository as well. Teacher repository as the interface, and that extends JPA repository, that is of type teacher and long, and I'll annotate with @repository. Now for all these particular things, you can define all the methods, different methods that we already saw in the prior part of this particular video, right? So for this particular teacher repository, let's create the test class, and I'll annotate with Spring Boot test, and I need private teacher repository, and I'll auto wire it. Let's create the method to save a teacher, okay, with the course. So I'll just say public void save teacher, and I'll annotate with test over here. I'll say teacher equals to teacher dot builder dot build dot first name equals to, suppose Kutab is a teacher, dot last name say Khan, and dot what courses this particular teacher is teaching. Now this particular course is taking the list of courses. Okay, so let me just create one of the course, or you can create one method to add the course to that particular courses list as well. Okay, whatever is feasible you can use that way. Ideally it should be you create one method that adds the course to that particular list of course. For the simplicity, I'll just do a cheating over here. I'll just create a course equals to course dot builder dot build. I'll just say course title equals to, I'll just say DBA dot credit is 5 and build, and I'll just use this course as list dot of courses. Simple. Now let's add the teacher repository dot save teacher. Simple, right? I just created the teacher object over here. This teacher is having a list of courses. I just added one course. Let me add multiple. Okay, I'll just say course DBA and I'll add one more course. I'll just say Java. This teaching Java, credit is 6, course DBA, course Java. 2 courses. This particular teacher is teaching 2 courses, so I just define this way. Now let's run this. So here you can see that it is successful. You can see that one teacher was inserted. After that 2 courses were inserted, okay, and those particular 2 courses were updated by the teacher ID that we have inserted. So let's go and see this. You can see that one teacher was created, that is Kutub Khan. Teacher ID is 1. And if you go to the courses over here, okay, and if I run this, you can see that this particular 2 course DBA and Java is created and it is taught by teacher ID 1. Teacher is 1 over here.